Hello and welcome all to the Android Reverse Engineering course. So this is a short introductory course to those who are interested in Android Reverse Engineering. We'll be covering everything from the basics in this course. So let me show you the prerequisites required for this course. And some amount of programming knowledge is assumed because we'll be mostly diving into Java applications. So it would be nice if you know the programming concepts about Java. You only need to know about the programming concepts. You don't need to program or write any scripts in this course. And next one is ARM basics. So there is a section in your course which will cover ARM reverse engineering. It would be nice if you know some basics about ARM and ARM instructions, mostly ARM32. So if you are a complete beginner in ARM, it basically covers everything for ARM and ARM exploitation. If you are interested, check that out. So next, you will be thinking, who can take this course? Anyone interested in Android reverse engineering or CTF or bug hunting in Android can take this course. This will help you in many ways if you are a complete beginner. So let me show you the course contents. This course will be very practical. We'll not be dealing with theories and stuff. We'll be just doing everything hands-on and learning by that. So the lab setup. The lab setup requires only some few tools. I'll be just covering that in one section. There are some commonly used tools for reverse engineering Android application. So we'll be doing a basic demo of these tools and we'll be using that in the later sections. So nextly Android basics. We'll be covering some basics about Android if you are a complete beginner. So we'll be covering the structure of the Android application and some components used in these applications, which will become handy when we are in the reverse engineering section. And after that, we'll be covering some smali so that you can understand and patch the application. We'll be dealing with smali a lot in the reverse engineering section, doing some CTF applications. Mostly in this course, we'll be learning by doing everything. There is almost 6 CTF applications, so we'll be doing that one by one and we'll be practicing by that. So this includes Java, Flutter and React Native applications. So we'll be doing these challenges one by one and we'll be improving our skills. This includes patching the application by editing the smali. After that, we'll be debugging Android applications and we'll be debugging Android applications. So after that, we'll be debugging Android applications using various tools. And after debugging using various tools, then we'll be reverse engineering Unity games in Android. We'll be dumping the assembly files and stuff. And after that, it is the ARM reverse engineering section. Section requires some amount of ARM assembly, so it would be nice if you know some ARM assembly. So if you don't, you can just skip this section or learn some assembly and come back. So these are all for this course. I hope you enjoy this course and I'll be seeing you there. Welcome back. In this video, we'll be looking at the basic components of the Android application. So this is pretty much self-explanatory and easy to understand. So if you want to look into this, you can just come to this website. I will just provide this link in the description so that you can just come back and refer to this if you want. So firstly, I will be talking about activities. So activities are just the basic presentation layer of our application. So anything you do in the application is said to be an activity. For example, if you are using a Facebook application, the login is an activity, logout is an activity, sign up is an activity, etc. So basically it is just setting the layout and displaying the output to the user actions. Okay, so if you look at the example, it shows you the main activity which extends or inherits from the activity class. This activity is seen in the Android Java application. So this is one example. Okay, if you want to refer to more, you can just click on this hyperlink. Okay, let us move on to services. So what are services? Services are like the components which run at the back end of our application, which means that it does something in the background. Okay, for example, it downloads something to your phone, it updates something to your phone, like updating an application or something. This all happens in the background, right? So these are the examples of services. So you can see a example of that. So next is content providers. So what are content providers? So they are basically an interface to communicate with the database or the stored data. Okay. For example, they can store the data from the application to the database, and it can retrieve the data from the database and give to the application for processing. So these are the one of the uses of these content providers. You can see an example of a Java code here. Okay, so nextly we will move on to broadcast receivers. Let's look on broadcast receivers. They are mainly used to listen for something. Okay, for example, when you are using your phone, if your battery is less than 10%, it will show you a notification or an alert. This notification only occurs when your battery level is less than or when it reaches like 10%. In this case, when the phone battery becomes 10%, this is like the broadcast here. Okay, so this will be received by the various applications of the phone and will alert you. So for example, if you are in a car, it will just say your battery is at 10%. Okay, so this broadcast will be received by the caller application. Okay, and it will just alert you or do something. If you didn't understand that, you can just refer to this article. So now what are intents? So intents are basically used to transfer data between various activities. Okay. So they can also send data or anything outside the application too. Okay. It can also send data to other applications. As you can see now, it is used to start and stop activities, services, broadcast messages, etc. These are all for intents. Next, we'll be looking at widgets. I guess you all would be familiar with widgets. So widgets are just small visual application that can be seen on your home screen. For example, you have seen that there are widgets like calendar, clock, etc. Okay. So next thing is notification. You will be also will be familiar with notification. So notification are just alerts used to draw the attention of the user. So that's all for the basic components of the Android application. So I'll be seeing you in the next video. Welcome back. In this video we'll be looking at the Android file structure. So firstly we'll be looking at this Android manifest.xml. So this is an XML file. As you can see that it ends with .xml. So it contains all the components of our application. For example, it contains all the defined activities, services, content providers, broadcast receivers, and so on. So it also contains the permissions. So this is the structure of our Android.manifest. So by looking into that, we can see all the activities defined in our application. Okay, so we can also see the permissions, broadcast receivers used, services used, etc. So this is very important if you are looking for something. This is very important because all the components of this application will be defined in the manifest. Okay, so let me show you the manifest in a simple application. You can see now there is a folder called manifest. If I just expand that, we can see the Android manifest.xml. If I double click that, we can see the Android manifest.xml of this application. So we can see the package name and the name of the application and its icon and other metadata, and we can see the activity, which is the main activity. This application has only one activity. Okay, so it only shows the main activity and it shows the intent filter. Okay, so as this is a small application, it only has this amount of lines in this manifest.xml. So let's move on and look at the another component. Okay, so next thing is the source code itself, And as you know it says Java, so it can be written in Kotlin or anything else. This application is written in Java, so we can see a main activity.java class. So this is the source code of this application. Okay, so nextly we can see the drawable folder. So drawable folder contains the resources like XML, vectors, bitmap images, etc. Okay, so let me show you where this drawable is located. So firstly we can go to this resources folder, and if we expand that we can just see the drawable folder, and we can see there are two XML files. Okay, so first thing is the background, second thing is the foreground XML file. Okay, so there will be another things like bitmap images or other images. So next we can look at the layout. So layout is basically just the user interface for our application. All the objects are placed in the layout. For example, I will show you. So this is the layout of our application. So as you can see now, there are three components in this layout. The first thing is called the text view. So this is used to embed text. Okay. Second thing is the button. As you can see now, this is a simple button used for clicking. And third thing is called an edit text. So edit text is basically an input field. So the user can enter the text into this edit field. Okay. So these three components are just placed on this layout. Okay, so this thing is called a layout. As you can see now, this says constraint layout. There are different kind of layouts in Android. I will not be going into that. Let's move on. And next thing is bitmap. So bitmap contains the image asset file that can be used in the Android Studio. For example, icons, action bars, etc. Okay, so let me show you the bitmap folder. So we can come to this resources. You can see the bitmap folder, and we can just expand that, and now we can see the icon of our application. So there is an HDPI and different HDPI and MDPI, HXDPI. Okay, so we can see that, and there is also an XML file. Okay, there is two folders in this map. So this is a folder for our icon of our application. So this is also a folder for our icon, but in this folder the icon will be round. Okay, so if we click that we can see it is round. Okay, so nextly I will show you that nextly we can look at the colors.xml file. So this file is used to define different colors that can be used in our application, where it is located. So we can go on to this folder values, and we can see colors.xml. So we can see that the name is purple, and this is the hex value. Okay, so we can see the corresponding colors in here. So this is all for this colors.xml. Let's move on again. Strings.xml. So strings.xml contains mostly the defined strings in our Android. So this is also next to our colors.xml. So we can see all the defined strings in our application. So the app name is crackme 0x3. Okay, moving on, we can look at the styles. This is just self-explanatory. This contains the style of our application, and build.gradle contains all the dependencies or the config used by the application. So this is pretty much all the basic structure for our application. So the main thing to note is that is strings.xml, name of the main components used in our application. Okay, so let me show you. If you go on to layout, and we'll be using these terms: edit text, text view, edit text and button. So you should remember what is this used for. This is used for embedding a text. This is used for entering an input. So this is a simple button. Okay, so that's all for this video. See you in the next. Bye. In this video, we will be discussing about various tools that will be used for our mobile application reverse engineering process. So firstly, we'll be looking on common tools that we'll be using throughout our videos. So let's go back and look at the tools. So these are the pretty basic tools we'll be using for our Android reverse engineering, that is APK tool. Easy APK tool, this is a relatively new tool, and JADX, so this is also an old tool, and GDA. So GDA is also a new tool, and we'll be using this APK tool and JADX and GDA. We will not be using APK tool, sorry, we will be using this easy APK tool, JADX and GDA. We will not be using this APK tool so much because it's very old, and this tool is very easy to follow, and as you have Windows, it will be pretty easier to use this rather than depending upon APK tool. But still, we will be looking into this APK tool. So let's go back and download this one by one. So for APK tool, you can just Google out APK tool, and you can go here in this website APK tool, and you can just download the latest version, that is 2.6, and click on download. Okay, so let's click on save file and it will download itself. And nextly, we can download this easy APK tool. Okay, so I guess this tool only works on Windows, so you need a Windows laptop, sorry, a Windows operating system, and we can go to this XDA forum, and you can just scroll here and you will find a Google Drive link, and you can just open that. Okay, this is a portable executable, you don't need to install it, you can just run it if you extract this. Okay, and let me download this. Okay, so you can just right click and press download. Okay, download anyway. Okay, and start the download, and after that we'll be downloading the JADX. So JADX is a pretty popular tool, and it is used by almost everyone doing Android reverse engineering. You can just scroll here and see this. So these are the different versions. So if you have JRE installed, that is Java Runtime Environment installed, you can just download this version. That is only 19 MB. If you don't have JRE installed, you can just download this and extract it. So I have already Java installed, so I will just download this. Okay, and you can just press on start download. So let's move on to our last tool, that is GDA. So GDA comes with a lot of nice features. So if you are doing reverse engineering or malware analysis on Android, this tool will help a lot. So let us download this, and there is a pro version and free version. So if you want to download the pro version, you can go ahead and pay them. So the pro version comes with a lot of features unlike the free version. So I will just stick with the free version for now, because using the pro version is outside the scope of this course. Okay, gladly for us, we only need the free version. So everything is set now, and we will be using this tool one by one on our basic APKs on the next video onwards. Okay, thank you. Bye. In this video, we will be looking at various tools on decompiling and compiling applications. So in this video, we will be looking at these four tools. Okay, so you can use any applications to do this, and I will be using this APK for this VLC player. So I will just provide the link in the resource section, so you can just use that. So firstly, we'll be looking at the easy APK tool. I already said that this tool is very easy to use and it's quite popular nowadays. So I guess this only works on Windows. So if you are using Linux, you can just use Wine to run this, or you can just use a virtual environment and use a Windows VM, and you can just use this tool. Okay, I don't know if there is any alternative to this in Linux. I guess if that doesn't work, you can just use Wine to emulate this. Okay, so let's look at the tool. So it has a pretty neat interface. You can just look at here and you can compile, decompile and also sign it. Okay, and you can just use alignment and install APK, zip APK, extract APK, etc. So let's decompile our application. So this is our application and you can just drag and drop it. So I will just drag and drop here and you can just press on decompile. Okay, so it will take some time and it will slowly decompile. So let me pause the video for now. Installation was successful, and one thing to note is you need to install Java runtime in order to run this tool. Okay, so you need to install that on your PC or your laptop. You need to install JRE on your system. Okay, so if you look at here, it says decompilation successful, and you can just navigate to the folder and you'll see this decompiled APKs. Okay, if you navigate to that, we can see the decompiled APK. So this is our application and this is the decompilation. Okay, so we can see the app manifest.xml and these are our smali classes. Okay, so it will not give a Java text class, it will be decompiling into smali. Okay, so these are smali codes, so you can look at here, it's all smali. Let's look at one on our, let's look it up in our notepad. So you can use notepad or whatever if you want. So I'll be just sticking around with notepad. So as you can see here, these are our smali. Okay, so if you look at this one, okay, so we can see that these are all smali. And let us go back. Okay, and this is our assets, and we can also look at the here, it's a Kotlin folder, and we can go back. We can also look at the resources. So this folder will contain the icons and stuff. And let's scroll down so we can see the XML. And if we just look in the values, where is the values? Okay, so values, you can see the strings. Okay, you can see the strings.xml. If you are doing CTF and stuff, you should mainly look it into the strings. Okay, so there will be a lot of defined strings in the strings.xml. And let me go back. So this is the decompiled form of our VLC player. Okay, so it was very easy, and if you look at the tool, and it is showing us the log output. Okay, it is using this APK tool to decompile this application. Okay, and you can just similarly use our normal APK tool. I guess this is very easier as this have a clean interface, and you can just look at here options. Okay, you can also look at the options, change the path of the decompilation or etc. And Okay, so this is all for this tool, and let's compile our decompiled application once again. Okay, to compile this you can just click on this select decompiled apk and go to our path which is on desktop, and we can find the desktop here. Desktop, and we can go to our folder names Android, and this is in the ECAPK folder and in the decompiled APK folder. So we can just click on this folder which is the decompiled folder of our APK and press OK. Okay, and now press on compile to compile this. So press on compile, so it will compile this smali and everything into a APK. Okay, so I will just pause this video once again, and our APK has been successfully recompiled again. So you can find that in our recompiled folder. So in this folder, now in this second folder, and if you click on that, you can see our APK. So this, if you try to install this will not work because it is not signed. But I guess with this version it says sign successful. I guess it will already sign this when we compile this once again. So even if that doesn't work, you can just sign it using this. Okay, let me show you, and we can just drag and drop this, and you can just sign the APK. Okay, you can just click on this and it will sign it. Okay, let me go here. So I think the changes would be overwritten to this file itself. So I think it is already signed. Okay, so you can also zip align this if you want, but I don't want to do that. So this is our APK and it has been signed successfully. If you run it inside your mobile again, it will work without any error. Okay, so that's all for this easy APK tool video. Next we will be looking at JADX and other tools. In this video we will be looking into our tool GDA. So GDA is a relatively new tool when compared to APK tool and JADX. So this is the free version. We'll be only covering the free version in this course. Okay, so still with this free version there are a lot of features in this. Okay, so let's run this, and this is the interface. Okay, we can just drag and drop the application like we did in our JADX. So let me drag and drop the VLC application. So it is scanning for that, and now we can see that we can just maximize this, and we can see that it shows us a chart of the dex elements. Okay, so how much percentage of methods, class, strings, type, field. This is pretty useful. And next, if you take a look at the side here, there is something called the basic analyzer. Okay, it gives us the basic information such as the manifest and strings, API, etc. So we can look at it one by one. So we can look at the base info. So this will give you some basic information like the permissions, the dex base info, metadata, and the file base. Okay, so it's not packed. And let's look at the certificate. Okay, so this is the app signature certificate, and if you look at the APIs, it will provide all the APIs used in this application. And all strings will give you all the possible strings in this app. If you are looking something particular like a flag or something, and this will help you a lot if you are doing CTF or something like that. And if you look at the app strings, we can see the strings which are hard-coded in the application. If you look at the all URIs, this will provide you the file path and the other URIs like the links used in this application. So if you look at here, it is using localhost. It has also a Play Store link, and we can see some files here. Okay, this is a file path, asset and license HTML, and we can also see a content provider here, and we can also see the Android manifest, and if you double click on this, we can see the manifest. And the most useful feature in this tool is we can filter this. Okay, so if you click on the receiver, it will only show you the broadcast receivers. Okay, and if you look at the click on the services, it will show you the services. And if you click on the permissions, and it will only show you the permissions. And you can use a you can also click on the activities, and it will show you all the activities. Okay, this is very useful. And after that, there is something called the mal scan. So this will scan the application and checks if this is a malware. Okay, it will give you enough information to check this if it is a malware or not. Okay, if you look at the resources, we can see the class. Okay, this is just loading. I just clicked on this resources.arc. So I think this will take some time to load this, so I will just pause this video. So it loaded the resource section, and we can see the all the resources values, and we can see the XML. And if you look at the strings, this will show you the defined strings. Okay, so this is the basic walkthrough of our GDA. This is the basic walkthrough of our GDA tool. You can also check the other things, like if you click on tools, there are tools like APK forensic, path solving, etc. So if you click on this, this will take some time, and we can just wait. And this is the APK forensics tool in the GDA. So there are some bunch of tools built into this GDA. You can just check it out and try it out yourself. Okay, we will we will not be needing all these tools in our course. We'll be looking at some basic stuff. Okay, so you can just check out other tools if you want. And I guess this is pretty much self-explanatory in almost all the tools. You can just easily drag and drop things and find out how these tools works. So I just made it because if you are a complete beginner, I want you to get familiar with this tool. Okay, so this is all for this GDA video. We'll be seeing you in the next. In this video, we'll be looking at JADX and GDA. In the last video, we have seen to use this easy APK tool to decompile and recompile applications. So in this video, we'll be looking at JADX and GDA. As you seen in our last video, when we extracted the application, the most DEX classes were in the form of smali. So you need to understand the smali code if you want to edit that. What will you do if you want to read the native Java code or the decompiled Java code? For that, you can use JADX or GDA. So I already mentioned that if you want to use JADX, you need to install JRE. So if you don't have JRE installed, please install it now, or you can just use JADX comes with JRE installed. So let us look on JADX. So you can just open that. So it's portable version. You don't need to install it on your computer or anything like that. It's a portable version. So this is the interface. So what we have to do here is we can just drag and drop the application to see the decompiled Java source. So this is the application, and you can just copy and paste it here. Okay, so let us wait. It is loading. Loaded, and now we can see the source code. So we can see every packages, and this is arranged nicely. So this is the resources, and this contains our assets, debug, Kotlin, and another folders, and also contains the rest folder, which contains our icons and strings, etc. So if we look at here, this is the Android manifest.xml. If you just double click that, you can see the manifest. So this is the manifest. You can see everything nicely here. So if you scroll up, and you can see the Java decompiled source code. So you can just click on com, and you can just click on the packages, and if you look at R, and you can see the Java classes. So you can just double click here, and it will load it into another tab. Okay, as you can see that it has successfully loaded that into another tab. And now if you look that, this is the decompiled Java source code. Okay, so it's very easy. You can inspect that in everywhere. So let me inspect another package. So if you look here and double click this, it will open that into another tab. You can just close that if you want. Okay, I close that, and you can see that it's clearly Java code. And this is the Kotlin class. So let me look at here. Okay, so this is package from Kotlin. You can inspect this like that. Okay, and you can just also search for various things here. So you can search for a string. You can just wait, it will once again decompile, and you can just enter the string. You can enter the text here, and you can also select the scope, and you can also select if the ended text is, say, a case sensitive or not. And if I just type VLC, it will print out all the classes containing that. And if I just press method, it will also show you that field code. You can select any of that if you want. For example, if I just untick this all and only select code, you can see that, and you can see where this VLC is reflected. You can just double click on that if you want to go to there, and it is showing where is this VLC reflected. So this is the code tab, and if you just double click on there, it will go to there. Okay, and it will show you that, and it will highlight that portion. Okay, if you look at here, it is showing in an yellow shade. So if you look at here, there is this VLC. Okay, so if you just click on this VLC, it will also show you the it will also highlight where this VLC is reflected in this portion. Okay, so, and you can just again search for something else and click on case insensitive. So it will result the search without any proper casing of the alphabets. And if I just type hello, and you can just select the scope. For example, if you are searching for hello in a method, it will print out that. So there is no hello in the method. Let me do it on a field code class. So there is no text as hello in this application. So let me change that to play. If I just type play, it will display all the results which this play word is used. Okay, so it will print out where this play is used in this class, method, field, code. And if I just double click on that, you can see that it is shading this portion. And if you just scroll here, you can see that where this play is reflected. So if I just look here, public class and play. Okay, so this is where the play is reflected. Okay, we can also use another tools. So this is for now. We'll be using these tools in our various app reverse engineering process. So we'll be looking into that more deeply at that time. Okay, so let me close this. I guess this is all for this tool. There is nothing much to explain on this. This is pretty much self-explanatory, so I don't have to do a deep dive into that. It has a search option. You can search for things, and everything is arranged in a proper order. You can just look into it and see what's interesting. Okay, so let me close that. You can also save this project, so I will just press no. Okay, welcome back. In this video we'll be looking at another application that is also used to reverse engineer Android applications. So the tool name is called bytecode viewer. Okay, let me show you the interface. So this tool is also used to reverse engineer Java applications too. So this is the interface of the application, and I will just provide the link in the description. So this is the website which I downloaded the tool. So all the features are listed here, and you can just click on download release, and it will redirect you to the GitHub page, and you can just download it from here. Okay, so this is the latest version, 19 days ago. Okay, I will put the link in the description. So this is the interface of our bytecode viewer, and this is the 2.11 version. So we can drag and drop the Java application or the APKs into here. You can also drop the Dex classes here. Okay, so what I'll do is I will just drag and drop one application, and we can see it's loading. Okay, this takes some time, so let me pause the video. So it loaded the application. We can see that crackme one, which is our name of the application, and we can see a plus sign, and you can just press on that. So we can now see the different components of our application. Let me show you the source code, and we can go to crackme, and we can just go to the main activity $1 class. Okay, so it will decompile this for us. So this is the source code, and this is using JDGUI decompiler. Here we can see the bytecode disassembler. Okay, so this is also the one feature of this bytecode viewer. It shows you the bytecode disassembly of the source code. It shows the bytecode disassembly of the Java. Okay, so you can see here, this is the bytecode disassembly. And another feature is you can go to this settings, and another feature is you can go to the view, and we can select different decompilers. Okay, you can just click on flower and click on Java, and you can just select another class. Okay, so it is now decompiling using flower decompiler. Okay, so this is also another feature. You can also select different decompilers here. Okay, so you can also see the smali. So you can also see the smali here. Okay, so this is an all-in-one accessory. You can almost see the decompilation, smali, and the disassembly too. Okay, so I hope you get this tool. For searching any strings, you can use here. For example, I will just type congrats, which is the string, which is a hard-coded string in our application. So you can see the result. If you click on here, it will go to where the string is located. Okay, you can see the string here. You can also close this. You can also close these tabs, and I'll just close this. Okay, and let me change the disassembly to JDGUI Java. Okay, and now if you double click here, you will go to the decompile Java source code. Okay, this is the string which we seen here. You can also filter here. Okay, you can check the string in a current class or all classes, and you can also select the string to a function call, method call, or regex. Okay, so you can just try it out by yourself. This is just the overview of the tool. Okay, so this is pretty simple. You can also look at all the strings using this option. It will take some time. So you can see here, this is almost all the strings in our application. You can also check out another plugins here. So if you want to see the manifest, you can click on view manifest, and it will show you the manifest. There are other useful plugins like malicious code scanner, show main methods, etc. You can just look it out and try it out yourself. Okay, you can also add new plugins here. Okay, so this is pretty much all the basic functionalities of this tool. So this is all for this video. So bye. Welcome back. In this video, I will be briefly introducing you to smali. Smali is very important when it comes to Android reverse engineering, especially on Java or Kotlin application. So, what is smali? Smali is like an Android assembly language. So, when we decompile applications, we may get the decompiled source code. But the drawback is that we cannot edit that decompiled code and recompile the application again. Okay, so we can just use it to understand the application. We cannot make any changes to the application by changing the Java code. It's not possible. So the way to do this, we need to learn the smali. So we can edit the smali and recompile the application. So this is one way to reverse engineer the application to change its behavior or something. So let us go through some basic smali fundamentals. Firstly, we can look at the keywords reserved by the smali language. So firstly, we can see it is field dot field. You can see that mostly everything has a dot in front of it. For example, if you look at method, so it has a dot in front of it. Okay, and you can see that there is a dot parameter which is used to define method parameters, dot prolog for defining method start, dot line. So we can see an example, dot line tol. So this says that this method is within line tol. There is a invoke super which calls the parent function. After that we can see an assignment. I will be talking about this later. Okay, so we'll be starting with the basic data types of smali. As you can see here, we have B for byte, C for character, D for double, F for float, I for integer, J for long, S for short, and B for void, Z for boolean. Okay, so these are the basic data types we can see in the smali, and we'll be moving on. So this is the syntax for declaring objects in smali. So L indicates that it is a object type. So this means this is the package where this object is located, and z which is an object name. Okay, so we can see the syntax, and there is a semicolon, okay, at the end of the object name. So after that we can see the array type. So this bracket and I represents two integer arrays. Let's move on, and these are the registers, main registers used in the smali. So v1, v0. So v0 is the first local register, v1 is the second local register. So there are v2, v3, v4, v5, etc. So these are mainly local registers, and other registers are these parameter registers. So there are p0, p1, p2, p3. They can be used to pass parameters. So let me show you that. So you can see here there are two type of registers, local registers and parameter registers. P0, P1, P2, etc. are parameter registers. They can be used to pass parameters to a function or a method. The registers and locals are defined using the dot registers and the dot locals label. You can see that here, dot registers and dot locals. And after that we can look at the methods. So this is the signature for our method. So method name, package name, object name, and a semicolon. Okay, this is the representation of the method. You can look at an example. This is a Java example, and it returns a plus b. There are two parameters, a and b, right? So firstly we can see the method is starting from a keyword, that is dot method, and the method ends using the dot end method keyword. So remember that. And this is the name of the method, and there are four locals. Okay, it means it is using four local registers, and there is a dot parameter 2. I guess the 2 is missing from here, so there is a 2 here. If it has the value 2, it means it has two parameters. And after that there is our line label or the line symbol, so dot 27. And after that it is moving p0 to v0. It means it copies a value from p0 to the v0. I'll be talking about this instruction later. And after that there is a dot local and v0. So it is copying the value from A to v0. So the v0 register is used to store the value of A and v1 is used to store the value of B. Okay, and it is doing some copy operation v0 to v2, v1 to v3, and it has an add instruction. I will just skip the instruction for now, and it is returning the value using v0, and after that the method ends. So we can look at another example here. Yeah, so this is a method, and we can see an z here. What this isn't z represents. So if you go back here, we can see an z here. It means this is a boolean method. Okay, so z means boolean. If you go here, we can see that z means boolean. So this is a boolean method, and we can see the number of locals, dot locals, and there are some operations going here, some comparisons, go to statements. I'll be covering that later. So this is all for this video. We'll be covering the other portions like constants and stuff in the next video. So bye. Welcome back. In this video we'll be continuing with our smali. So I will be covering some more smali in this video. So let's get right down to it. So firstly we'll be talking about assigning values to registers. So we can see an example. Oops, I will just close this. So we can see an example. So the register is v0 and the value is v1. So this part is a destination and this is the source. So this means that it is assigning the value to v0, and there is a keyword here, constant /4. So what is this 4 represents? 4 represents the size of the integer, which is 4 bytes, and it is a constant. That's why it has a constant /4. Okay, 4 represents the size of the integer. So it is copying or putting the value 1 to v0. Okay, so after that I will show you another example. So here it is copying the value 0 to v3, and here it is copying the value 12 to v1. You should be careful because this is in hex. You can see the x here. We can see another example. So this is copying a string to v0. As you can see the keyword here, constant string. So it is copying the string to v0. And another example is seen here, is copying the string Eric to v0, and the keyword is constant string. So let's look on some conditional statements in smali. So this is really important when it reaches our reversing section. We'll be seeing this a lot. So let me explain some of these important conditional statements in smali. So firstly we'll be looking at if eq. The operands of this conditional statement are registers. We can see an example here. So if eq and va comma vb, so these are two registers. For example, we can consider this as v0 and this is v1. So if both are equal, eq means if va equal to vb, then jump to condition x. So we can define a label here. So if both v1 or v0 is equal, it will go to this label. Okay, we can define a label and it will just go to there if these both registers are same. Else it will continue on executing the code below this conditional statement. So let's look on the next conditional statements. If any means not equal. So if va and vb are not equal, then it would go to this level. va can be a register, vb can be a register. For example, it can be v0 or v2. So if v0 and v2 is not equal, it will go to this defined label here. or else it will continue executing the code below. So there is other conditional statements like less than or equal to, greater than or equal, in less than or greater than or equal to. If VA is less than VB, it will go to this particular label. We can see that if VA is less than VB, then it will go to this label. So similarly, if VA is greater than VB, it will go to this particular defined label. So these are all just self-explanatory. And if you look at here, in this EQ and NEQ and these conditional statements below, this only have one register as operand. In here, what this EQ means? EQ means if this register VA, it can be V0, V2, V3, any register. Okay, so if that register is 0, if it holds the value 0, it will go to this particular label, or it will keep on continue executing the code below. So we can see that if V is equal to 0, then jump to this label. So similarly, an EQ is just the opposite. It means that if VA is not equal to 0, then it would go to this condition. Okay, otherwise it will keep on executing the code below. So there are other similar ones like less than 0, then jump to this condition, and greater than or equal to 0, then jump to this condition, greater than 0, and then to this condition, less than or equal to 0, then jump to this condition. Okay, now let me show you a real example of this conditional statement. So let me go to my Android Labs folder and easy APK tool. So let me show you the smali. So we can see a conditional statement here. So there is only a one parameter register. This is using not equal to 0. So this means that if p1 not equal to 0, or it means if p1 not contains 0, then it should go to this label. So we can look on the label condition underscore 0. Here we can see that cond underscore 0. So if p1 contains 0, it will not jump to this label. It will keep on executing these lines of code. It is checking if p1 not contains 0. P1 does not contain 0, it will go to this label. So when the execution reaches here, it will check what is the value of p1. So if it is not equal to 0, the condition is satisfied and it will jump to this label, or else it will keep on executing this code. So when it jumps to this label, it will skip all the code and it will only execute the lines of code from here, from this condition underscore 0. Okay, so this is the one example of our conditional statement in smali. So let's move on and to try to look on more instructions in smali. Let me go to the example in this previous video. So we can see a move instruction. So in move instruction, the first register is the destination and the second register is the source. So in this move instruction, it is copying the value from P0 to V0, and similarly it is copying the value P1 to V1, and it is copying the value from V0 to V2, the example for move instruction. And after that it is doing an addition. In this video, we'll be continuing with our smali section. So we'll be talking about some basic instructions and we'll be winding up this section. So firstly, I'll be talking about the nope instruction. So the nope instruction means no operation. It simply does nothing. Okay. When the nope operation is encountered, it simply does nothing. It just only keep on executing the next instruction without affecting anything. Next, we can look at the return instruction. There are some couple of move instructions mentioned here. You can look at the examples. I already talked to you about this in the previous video. So this is our return instruction. So return void means it does not have any return value. Okay, and if you look at return vx means it returns some value. The value will be returned in some register. For example, we can see return v0. So returns the return value in v0. We can see other return statements like return void, return object, etc. So return void returns the value in vx and also vx plus 1. For example, we can look at here, it returns the value in v0. So it will return a long value in v0 and v1. So as it is a long value, it may need more than one register. So it is using v1, sorry, it is using v0 and v1. Return object means it will return the object in this vx register. So for example, we can see that return object v0 returns the object reference value in v0. So these are all the main return instructions, and let's go on below. Next we can look at other instructions. So we can see other assignment instructions here. So const bar for vx and lit4, so it will put a 4-bit constant into vx, and similarly this part will be immediate value. Okay, for example, we can look at here const v1 comma into, so this will move the value 2 to v1. It means that 2 is an integer value, that's why there is an ampersand in here. So there are other assignment instructions here. These are the sizes. Okay, so you can just look it at by yourself. We can move on and look at the go to instruction. So this is the go to instruction. So go to instruction is simply just an unconditional jump, meaning it will just go to that label or that location without any condition. Okay, for example, if you can see here, go to 005, when the execution reaches here, the execution flow will go to this location. It will continue executing on the code from there. So nextly we can see a size mentioned go to statement. It is an unconditional jump by 16-bit offset. Next we can look at some compare instructions. So there is a compare less than float, greater than float, double, and greater than double. It compares the float value in two registers and set the integer value in the destination register. So these are the two registers to be compared, and it will set the result in v0. So it will compare two float values and set the result in v0. So what comparison occurs here? So it will check if v6 is less than v7. Okay, similarly there is a compare greater than here, so it will compare the values in v6 and v7. It checks if v6 is greater than v7 and sets the value in v0. And there are other compare instructions like less than, greater than, in double, etc. You can just read this example and just understand this. I will just provide this link in the description. And next we'll be looking into arithmetic instructions in smali. So these are the basic arithmetic instructions in smali. So there is an add instruction. So add instruction adds two values in the register, puts that value into the third register. For example, these are the registers which holds the value to be added, and the destination will be in this vx register. For example, you can see that add int v0 comma v2 comma v3. So it will add the values in v2 and v3 and put the result in v0. You can see in here, it means it will be adding integer values. So we can see that it adds v3 to v2 and puts the result in v0. Similarly, there is a subtract instruction. So it will subtract vz from vy and put the result in vx. So we can see it will subtract v3 from v2 and put the result in v0. And similarly there is a multiplication and division. Okay, and there are instructions like and, or, so, etc. So there is a shift left, shift right. You can just look at the example and Just try it out yourself. I don't need to explain every instructions because there are many instructions in this manual. We only need the basics so that we can understand at the high level. So these are pretty much all the arithmetic instructions in smali. Next we can look at function calls in smali. So these are the function calls. It uses this keyword evoke. Okay, so let me show you an example. So we can see the call instructions are evoke direct, evoke ritual, evoke static, evoke super, evoke interface. We can see the call format, evoke instruction type, that can be direct, ritual, static, super, interface, etc. And the parameters to be passed to this function. And there is a comma and the L and the class name and a semicolon and this arrow and the method name. So we can see an example here. So this is assigning the string to v0 and it is evoking this function and passing v0 as the parameter. So we can see v0 is in here and this is a invoke static, and this is one example. Let's look at the another example. So v0 contains the string Eric and it is invoking this function. Okay, it is invoking this method and the parameter is v0 and the result of this function is moved to v2. This result moves the result from the last invoked method and moves the result to the mentioned register. Here the register is v2, so the result will be moved to v2. Let's look at the example we looked in the previous video. So this is the function and we can see the parameters and the prologue and the line. So it is moving p0 to v0, p0 to v0, and there is a local parameter v0 and it is moving the value p1 to v1, and after that there are other move instruction which will copy the value of v0 to v2 and the value of v1 to v3, and after that it is adding to, okay, so it adds v2 and v3 and puts the result in v2, and after that it is copying the value from v2 to v0 and it returns v0, and we can see the end of the method using the dot and method keyword. So this is the walkthrough of this function. So these are all the basic instructions in smali. I will just provide the link in the resource section so that you can just walk through all of this. So this is the wind up, I guess. So it's time to wind up this section. We'll be seeing this smali more in our reverse engineering section. Welcome back. In this video, we'll be reverse engineering a CTF application with the help of the tools we learned in the earlier section. So we'll be looking at a CTF application and we'll be reverse engineering that and we'll be analyzing how to solve that. Okay, so let me show you the app and how it looks like. So I casted my phone screen on the laptop, so you can see here. Oops, let me connect this once again. So this is our CTF application, and as you can see here, it is asking for a password and it is a button called check. Okay, so we can input something into this text field, and if you click on check, let's see what happens. So I will enter something random and press on check and it says sorry, try again. Okay, so what you have to do here is we have to find the value which should be entered into this text field, which will return the correct message or the congratulation message. So our task is to reverse engineer this application using the tools which we learned from the previous section and get the correct key that is used in this application. So that is the first thing, and second thing is that we need to patch the application so that whatever we enter in this input field, and if we click on the check button, it should print us the good message. Okay, so it should not be comparing with the hard-coded value. It should be working in the way that whatever we enter, it will just print out the correct message. Okay, so we need to try to patch the application in that way also. So firstly we will try to get the hard-coded key which this input is being compared with. So let's use the our tools which we learned from the previous section. So one of the way to do this, we can just if the hard-coded value is a string, we can just print out all the strings in this application. So we can use the GDA for that. Okay, so you can also, if you are using Linux, you can also use the string command. I will show you that later. So firstly we can just go on to use our GDA and check the hard-coded strings in that. If our input is compared with the hard-coded value, we need to do is that we can like reverse engineer and find all the strings and look for the suspicious strings which may or may not be the hard-coded value. So we can just do that by a try and error method. So if that doesn't work, we can just go on to another tool and reverse engineer the source code, and we can reverse engineer the application and decompile to get the source code, and from then we can analyze the application and get where the comparison is made from, or the validation. What I mean by validation is that in which part this input is being compared with the hard-coded or runtime generated value. We don't know which is the one in this application. I guess if the value is a hard-coded string, we'll be lucky. If it's not, we can try to decompile the source code and we need to analyze from there. So let's try our luck, and we can just use GDA to find out all the strings. So I will just minimize this. Okay, so this application will be provided in our resource section. So these apps are played by most security enthusiasts and also mostly the CTF players. So this will help us to get on a hands-on experience on reverse engineering these applications, and this will help us to improve our skills. So that's why I made this application. This is a very simple CTF application. So we need to build the foundation before just jumping on other practical applications. Okay, so this is the first application, which is crackme 1. So this is the application which I showed in this screen. Okay, so let me do GDA. So what I will do is I will just I guess this is the application crackme 1. Okay, and I will just copy it once again. So I will replace that, and I will just drag and drop this into GDA. So it's loading in GDA, and what we have to do is we need to find all the strings. Okay, we need to check if the password or the value is a hard-coded string, and if that's the case, we need to only get the strings of the application and look for the suspicious one which may or may not be our password. So let me go on to app strings, and here it will print out all the strings in our application. So let's go down and look for something suspicious. So nothing much. These are other strings in our application. So if you look above, there is something called super secret password. Okay, so I don't know what is that, but this looks suspicious, right? So let me go down, and there is password. These are labels, like it has double columns, and if we go down, there is nothing much. Okay, so let me try the first one and check if that works. Okay, so let me go up, and this is super secret password. So there is a 5 and 3. So there are 2 3s. Okay, let me try it. Okay, let me just connect to this once again. Okay, and this is our application, and we can see that this is our guessed password. Okay, this may or may not be the password. Let's try it out anyway. So let me type 5 secret, and there was a 3 there, and I guess there is a 3 here also, and password. Okay, let me check. Okay, secret password, and if you click on check, it says congrats you won. So as you know, this is a good message, and this is all for this application. So luckily for us, this was a hard-coded string. So we can analyze this in our JADX to find out more. So let's also do that. And so you don't need to use JADX. We can see the source code in GDA too. So if you go on com and AD 2001 crackme, so this is where the source code resides. And if you click on main activity, we can see something. So there is the main activity, and we can just look down for main activity 1, and if you look here, it is using a toast to print out. So this thing we saw in that application, congrats you won, and the sorry try again, is called something called a toast. Okay, so we can see our sorry try again message and congrats the good message. Okay, so we can see it's making a comparison. Okay, so let me explain the logic here. It is comparing two strings. So the first string is where from the input field, as I said earlier. So it is comparing that to this string, which is a hard-coded value called password. So where is this password resides? This password comes from the P2. So we can check where is this P2 coming from. So let's see where is this P2 is coming from. So if I just go into my strings, and where is our super secret password? Yeah, and we can just do a cross reference, and if you just scroll here, and there is our password. Okay, so if you go back to the main activity, and we can see that this p2 is an argument to this main activity. So we can go again to the main activity, and if you just scroll here, we can see the super secret password. So this is passed as the second argument. So this is the first and this is the second, and if you look at one, this is the third argument. Okay, so this is the first, the second, and the third. So the p2 is the third argument to this main activity function, and if you look here, this is where the main activity function is used, and the third argument is the super secret password, which is passed to the main activity $1 function, and it is stored into this variable password, and here it is compared. Okay, so I guess you got the logic, and if you want to get a cleaner understanding, we can use the JADX. So I personally think JADX is better than GDA in terms of this uh, decompilation. And we can just open this and we can just wait for it time, and it is loaded. So we can just go to AD 2001 crackme main activity. We can just double click on this, and if you look at here, this is more accurate, and this has more clarity than the source code or decompilation in the GDA. So if you look at here, it is comparing one string to the another. So super secret password, which is our hard-coded string, which is compared against, and it is comparing the input value which is get from the edit test, and it is converting that into a string, and if it's checking if that is equal to the hard-coded password. If this is correct, it will print out congrats, you won, using the toast. And if it's not, it will do another toast, and it will say sorry, try again. So this is the first CTF application. So I hope you liked it. Let me see you in another video. Bye. In this video, we will be reversing the previous application and patching that application so that whatever we enter in the input field, it will just print out the good message, or it will toast out the good message. So in the previous video, we have already reverse engineered this application using JADX and GDA and found out the hard-coded password. So in this video, we'll be patching that. So what do you mean by patching? We will be editing the smali code so that whatever you enter, you can enter any random text and it will just print out the good message. Okay, this will be the purpose of this video today. So we can just decompile the application first so that we can obtain the smali code. So let me show you the application. The application is the same application from the previous video, that is crackme1. So we can just decompile this using APK tool or easy APK tool. I prefer the easy APK tool because it's very easy and simple. So let me go on and open this easy APK tool, and let me drag and drop the application. So this is our application, and let me just drag and drop that here, and we can just click on decompile. So why are we even decompiling this? So that we can obtain the smali code. Okay, we need to edit the smali code and we need to recompile that again so that it will have that patching effect. So let me wait until this get decompiled. As we can see now, the decompilation is now successful. Now we can navigate into the easy APK2 folder, and we can navigate into the decompiled APKs so that we can see our decompiled APK. So this is the name of our application, crackme1, and if we navigate into here, we can see the decompiled files. Okay, so we'll not be covering all the smali code. We'll be only focusing on the part which we need to patch. Okay, so we'll not be deep diving into smali. Okay, smali is a bit difficult to understand. We'll be only looking at the surface level so that we can patch this and get it to print the good toast message. Okay, so we'll be only doing that part. As we are not experts in smali, we'll be using the help of GDA, and we will compare our decompiled Java and the smali code to get the part which we need to patch. Okay, so this is the smali folder, and we can go to the com and our application package name AD 2001 and our app name. So this is the decompiled smali. Okay, so we can see there is main activity $1 and main activity. So let's go into main activity. Okay, and we can see the super secret password here. So the one way, as you know, this is a small CTF application. If this is a big application, it will have a lot of smali code. So what you have to do is you can just use a code editors like Visual Studio, and you can just drag and drop this into this Visual Studio, and you can just use various search to find the place which we need to patch. Okay, The easy way to find the location where we need to edit the smali is that you can use tools like JADX or GDA and compare the decompiled Java with the smali code. Okay, so in that way you can just find the location using the decompiled Java, and that will make the entire process very easier. Or the next way is that you can just search for the error message. Like in this application, we know that if you enter the wrong password, it will print out the wrong toast message. It will just print out, hey, your password is wrong, or try again, whatever. So we will search that in this smali code, and in that way we can just find the location where this logic or comparison lies. So as this is a small application, we only need to look in the main activity. There is only one activity in this application. If this is a big application, you can use this any IDE and use any search options. Okay, so firstly I will show you the easy method. So let me go back and use JADX. So let me go on here and use JADX. Okay, so and we can just load this application once again. We can wait until this loads. Okay, and we can just go to edit 2001 crackme and main activity, and we can just double click on that, and we can see our comparison. It is checking if this input string from the edit test, that is from our input field, is equal to the hard-coded password, which is the super secret password. So we can just minimize that here, and what we can do is we can look at the activity. As you know, there is only one activity in this application, that is in the main activity. So we can just go around the APK tool and navigate to our decompiled application and go to main activity 1. So there is main activity $1 and main activity. Let me check one by one. Okay, so if you look at here, this is the smali code, and we can see the our hard-coded password here. Okay, if you look at it in this smali code, there is no error message. Okay, so if you go and look here, it says congrats you won and sorry, try again. This is our error message and this is our good message. So look for the smali code where this error message and good message lies. Okay, and if you go on here and scroll here, we can see sorry, try again and congrats you won. Okay, so we found the good message and the bad message in the same smali. So this indicates that this will be the one to edit. Okay, so I guess this will be the smali class to edit. Okay, so let me go on and unlace the error messages. If you look here, it is our error message, sorry, try again, and it is going to the toast, and it is using the make test, and it will just show the toast. Okay, and if you just go above, similarly this is our good message and it is using the toast, and it will show the toast. There is our show. And if you go here, first thing we need to look is for a conditional statement. Okay, we need to look for if enc, if any z, etc, etc. Okay, look for anything like suspicious, like if you go around, you can see that there is an if. So the place to look for this if is near the error message or the good message. So this is our message from the toast. This is the message from our another toast. Okay, this is the good message toast. This is the bad message toast. You need to look for the smali conditional statements near this error message or the good message. Okay, so if you look at here, this is one conditional smali statement. Okay, and there is no other smali conditional statement near this good message or the bad message. So this is the closest one. Okay, so this is the closest one, and what you have to do next is, if you just scroll above, we can see some hints. Okay, so it is using the string compares. Okay, it is checking if that is equal, and this z represents boolean as we said in the first video. This is comparing the text from our input field with the password. Okay, we can see our password variable, and it is invoking the string compare method. So if we go here, this is our equals. Okay, and it is comparing the two strings. Okay, and the result will be moved to this p1. Okay, so this is a boolean. The thing here is, if the string is the same, it will return true. Okay, true means 1. If the string is not same, it will return 0. That means it is false. Okay, let me give you a case. If you enter something into the input field and click the button for comparison, and it will compare that with the hard coded password. Okay, so if it is same, it will return true. So imagine if you entered the wrong password, so it will compare both strings and it is not equal, so it will just return false. As you know, this z represents boolean, so it will return false. So what's the value of the false? 0. So it will be moved into this p1. As you can see that firstly it is our string comparison followed by the conditional check. So we need to bypass this conditional check. We can see the syntax of this conditional smali statement. There is p1 and comma a label. Okay, so if you look at this label, conditional underscore 0. Okay, if you go here, there is the conditional underscore 0. So if you go down, this is the wrong message. Okay, so if the program flow go to here on this label, it will just toss out the bad message. So what happens here is, when we enter the wrong password, this p1 will contain 0. So what will happen next is, this will check if this p1 contains 0. If this contains 0, it will go to conditional 0. Okay, condition underscore 0. So if it is checking that if the value of p1 equals to 0, that's what this conditional statement means. Okay, it is checking if the value in p1 is 0. If the value in p1 is 0, it will go to here. It will go to this label. So if you go down this label, this will directly print the error message. If you enter the wrong password, that will be the case. Okay, but if you enter the right password, p1 will contain 1, and it will check the p1 it will check if p1 is 0. But as we enter the right password, p1 will not contain 0, so it will not go to this conditional underscore 0, but it will go to this line of code. Okay, and it will go to here, and it will just print out congrats you won. Okay, so this is what this conditional statement does. So what will we do if you want to bypass this condition and go to this part, which will just toss the good message even if you enter the wrong password? So the easy trick is, we need to just change or inverse this condition. Okay, so there is a smali conditional statement which is NEZ, which means not equal to. Okay, so what this will do is, this will check if p1 contains not 0, it will go to this condition 0. Okay, in this smali condition, what will happen here is, if this p1 contains any value other than 0, it will go to this condition. Okay, otherwise it will execute the code below. So this is just the opposite of the conditional statement which we saw earlier in this line of code. Okay, this is just the opposite of if EQ is set. Okay, so this will do the job here. So even if you enter the wrong password, p1 will contain 0, right? So this will only go to this condition if p1 contains 1. So as you know, if we don't know the password, so if we enter the wrong password, this p1 will contain 0. In this condition, if the p1 contains 0, this will go to here and we will get the lost message. So this is the easy way to change this. Or what we can do here is we can just copy paste this code and replace that. Okay. We can copy this code and replace that to here, and we can just copy that to here. Okay, so what will happen here is, even if you enter the wrong password, you and even if the condition is not bypassed, the code here will be this good message code. Okay, we can get the good toast, but that is not a good method, because we are just copying the good message into our place. So I don't think that is very practical. So I think the good way is to just change this condition to its opposite, that is NEZ. Okay, so let me save this and now everything is done. Now we can just recompile our application. Okay, so we can just go to APK tool and go to the decompiled folder and we can just copy, oops, and we can just drag and drop this into here, and we can just press on compile. Okay, and we can wait until this recompiles our application. So this was a very simple technique. We only need to reverse the conditions. Okay, the only thing we need to know is about some basic smali conditionals, so that we can just invert the current condition to its opposite, so that we can bypass the current checks. So it is compiled successful and it is already signed. Let's just install the application and check if that works. Okay, so I have successfully installed our patched application in my phone. So what you are seeing here is our recompiled application. So let us try if our patching worked or not. So let me enter any random input and press on check, and it says congrats, you won. So we are getting the good message without even entering the correct password. So so I guess our patching worked correctly. So let me try with another text and press on check, and it is still saying congrats, you won. And let me do it one more and press on check. It says congrats, you won. Our patching worked successfully. But there is one case: if you enter the right password and press on check, it will say the password is not correct. Why? We only bypassed the condition, not the logic. Okay, so if you enter the right password, it will print out the wrong toast messages, because we inverted the conditional logic. Okay, so this is all for this video. We will see you in the next. So bye. Welcome back. In this video, we'll be solving another crackme challenge. So this is also similarly a CTF application like before, but the functionality of this app is different. Okay, let's see the application. So as you can see now, I am mirroring my phone screen. So this is the application, and there is a button, click me. Okay, let's click it. If you click it here, there it says 99999 and 8 clicks remaining. So each click, this will be decremented by 1. So when it reaches 0, it will print out the flag. So what you have to do is, we have to reverse engineer this application and find the flag. Okay, we can also patch this or edit the smali of this application, so that we can get the flag very easily. Okay, the easy way will be to patch this application so that we can get the flag very easily. Like, we can change this value to 0, and when we click on the button, it will just print out the flag. So let's look at the application now. I will just minimize this and let me go to my Android folder. So this is the APK. This will be provided in the resource section, crackme 2. So let me first close this once again, and let me just drag and drop this to GDA, and we can just check for if any hard-coded things. Okay, all strings, and if we look, we can look for the bad and the good message. Okay, you can see congrats, you got the flag, clicks remaining. And if you go to here, congrats, you got the flag. Okay, we need to click the right click and cross reference. Okay, and then we can click here. Okay, we can see the Java code here. Okay, so it is using a toast, and it will just say congrats, you got the flag. So I think it will be better if you use JADX. Okay, you can also use GDA, but I think it will be better if you use JADX. So I will just open JADX, and we can just wait. Okay, and now we can open the crackme application. Okay, let's wait. Okay, let me go into com AD 2001 crackme 2 main activity. So let me inspect the code and see what happens inside this application. We can see the code more clearly than GDA, right? I think it would be better if you use JADX. And if you look at here, in the onClick method, there is something called click. If you look here, click is initialized with a value of 0. And if this equals to this, I think it's 69, then it will just go to here. Okay, let me look what happens. And there is an method called flag. So we can look at the method called flag. So this will print out if this click is equal to 9999999, it will just toss this message, congrats, you got the flag. And also there is something happening here. This is some kind of function. You can see the flag format, but this is not actually the flag. Okay, and it will be returned. So there is some kind of computation happening on the string, and it is returned. Okay, after returning that into this pass variable, it is also a string type, and it is initialized with null. And after some operation on this hard-coded string, it will be returned. Okay, and that will be put into this variable, and after that this string will be set onto the text view. Okay, so this only happens if we pass this check. Okay, if the number of click is not equal to this number, it will go to this part and it will increment the click. Okay, so imagine if it is the first time you are opening the app, and if you click on the first time, this 0 will be incremented to 1. Okay, and after that it will set the text view to the number of click remaining. Okay, after setting this text view to this number of clicks remaining, it will toss out this message, keep clicking. Okay, so let me look at this function flag. If you are familiar with CTFs or any of this stuff like that, you should be familiar with this code. Okay, this is actually the code for converting a text into rot 13. It rotates the character by 13 characters. Okay, so this is actually the Java implementation for rot 13. So if you need to get the original string, we can just use any online rot 13 converters, and we can just perform this and get the flag. Let me do that. So this is a good website for converting the text into rot 13. You can just look at here, rot13.com. So what I'll do is I will just copy this text, and we can just copy that and we can just paste it here. And if you look at it, it is already converted that. So this is our flag. Okay, flag is equal to you got it. Okay, so this is one way of doing that. Another way, we need to patch this application so that we can easily print out the flag. Okay, so let me do that. now. So let me close this. So we already understand the code. So let me decompile the application and we can edit the smali. Okay. So we can go to easy APK tool and open that. We can go back and drag the crackme tool. Okay. And press on decompile. And this will be decompled in a second. So let me pause the video for now. So now the application has been decompiled successfully, and now we can navigate into the decompiled APKs folder, and we can go to our application, that is crackme 2, and we can go to the smali folder, and we can go to com, package name, and the application name. Here are our decompiled smali codes. So as you know, our application is a very small CTF application. It only has one activity, that is the main activity. So we don't need to look into other smiley code. We only need to look into this main activity smiley code. So let me open this. As you can see now, this is our main activity smiley code. Here is our message, keep clicking and toast. And let me close this one and let me open this. We can see our route 13 flag and the good message. Okay, so next step is to find where to edit or patch this application. I already said this in previous video. If you don't know much about Smiley, we can use the help of Java. So let me go back and open GD again, or we can use JADX. I think JADX is better. Let me open JADX once again. And we can do is we can just compare this Smiley and our uh, Java code side by side so that we can understand it better and find the part which we need to patch very easily. Okay, so let me open this again, and as you know, we only have one activity, which is our main activity, and we can just minimize this for now and again navigate into the our decompiled folder. First things first, we need to find the place where we need to patch. So let me maximize this again. Take a look at this Java code. It says if the click is this number, it will invoke this function, which is our flag function, which returns our flag. And after that, it will set the text view to the flag. Okay. So we know that firstly, it will invoke this flag. Secondly, it will set the text of this text view to our flag. Okay. So we need to find that in our smiley code. Okay, firstly we can open this and look around for any conditional smiley statements. So let me maximize this and we can go and look on for any if. So there is one if, and okay, there is only one if in this. Let me examine this condition. Okay, so firstly he is checking if v1 is not equal to v0, go to this condition. So let me go on to conditional 0. So let me look into conditional 0. There is conditional 0. Yeah, this is the conditional 0. So if you look at here, there is something happening here. And we can look at the text messages to understand what is happening. Here it is loading clicks remaining. Okay. After that it is loading the string keep kicking to v1. So v1 is a register, and after that it is showing the toast. As you know, this message keep clicking will only appear if our number of clicks is not equal to the large value. So let me go on above and see what's happening. Okay, this is where it will just set the text view to the number of clicks remaining. Okay, here is our text clicks remaining. After that, it will set the number of remaining clicks in the text view. So we can see the text view here. So this is the text view and it is setting that. Okay, so this conditional 0 executes when our click is not equal to 0. So if our click is equal to 0, we will get the flag and the text view will set the flag. Okay, so let me go up and look at here. Where was our conditional statement? So if p1 not equal to v0, if p1 not equal to v0, it will go to conditional 0. That means our click is not equal to 0, it will go to here. So let me look into p1 and v0. p1 is equal to number of clicks, okay, and v0 is equal to total. What is total? If you go up, we can see where this total is set. Okay, it is coming from main activity. Let me minimize that and go to here, and the thing is every numeric value in this value will be in hex. Okay, so there is some hex values here. We look at here. Okay, there is a hex value and there is a hex value, and if you use the calculator and if you just copy this and we can check that. This is our number of total clicks. Okay, this is passed from main activity.smali to this main activity $1 smali. Okay, so our total is this number 99999. Okay, so that is our total, and the number of clicks is initially 0 and it will be incremented by each click. Okay, so this is checking if this both are same. If this both are same, it will not go to this conditional, it will execute this code. Okay, so as you know, v0 will contain the total, v1 will contain the number of click. If it is not equal, means that the click is not equal to total. We are incrementing the click by 1. Okay, initially the click is set to 0 and it will be incremented. If the click is not equal to the total, that means if the click is not equal to this value, it will go to here. Okay, otherwise it will go to here. So let us examine what this code represents. So if I maximize this and if you look at here, it is calling the flag method. Okay, it is calling the flag method and storing that return value into v0. If you look at the flag message, a flag message convert this into row 13 and return that. Okay, so if this condition is satisfied, it will call the flag method, and after that what will happen, it will set the text view to that flag. Okay, so this is the code which we need to execute. Okay, so we need to execute this code so that it will print out the good message and it will set the flag to our text view. So the place to edit the smiley is here. So we only need to change the condition of here. If we invert this condition, we can easily execute this code and we can get the flag. Okay, so so we can invert this condition. Okay, not equal to here this condition represents not equal to. So what we can do is we can just change this to its opposite. What is the opposite of not equal to? That is equal to EQ. Now what will happen here is, even if these values are not the same, it will execute this line of code. As a result, we will get the flag. Okay, and this condition will be executed only if p1 and v0 is same. Okay, otherwise it will execute this condition, as you know. So this EQ is just the opposite of the NE. Okay, so in this condition, if p1 and p0 is equal to the same value, that is this value, it will go to conditional 0. Otherwise, it will execute this code. This is what we want. It will just toast out the good message and set the text of the text view to our flag. Okay, so we have done the patching process. Now we can just save this. Okay, I hope you understood. We only changed the condition to its inverse. Okay, so that it will execute the code we want and we will get our flag. Okay, so let me just close this and we can now recompile our application. Let me open ECPK2 and let us drag and drop the folder. Okay, let me compile now and wait. Now I successfully installed the recompiled application. As you can see now, this is our reverse engineered application. And if you click on click me, you can see that it shows the good message and set the flag. Okay, so we have successfully reverse engineered our application so that it will print out the good toast and the flag. Okay, so another easy method to do this is we can go to the smali code. We can change the value of the click. Okay, it's also an easy method. We know we only get the flag if our click is equal to this number. Okay, this large number. What we have to do is we can change this number to a small number so that we can get the flag. For example, we can change this to 0. Okay, hexadecimal to 0, and we can edit this in our smali code. So this is the value. We can just set it to 0. Save this and recompile this. Okay, and now if you install this application, you will get the flag in one click. You can also do this in that way. Welcome back. In this video we'll be doing another crackme challenge. So this crackme will be different than of the last two crackmes we did in the previous video. So let me show you the crackme looks like. So let me mirror my phone screen. So this is our crackme tree and it has an input field and a button. So let me enter some random input and press on check. It will print out, oops, try harder. This is the bad toast message. If you enter the correct password and press the check button, it will print out the good toast. Okay, so let us now reverse engineer this application and see how this looks like. And I will just close this, and this is the application. Okay, so this is the application crackme 3. This will be provided in the resource section of our codes. And let me drag and drop this and analyze this using GDA first. So firstly we can look for any suspicious strings and we can go to app strings, and if you look now, okay, let me scroll below. So it seems like there is no suspicious hard-coded strings. So I guess we need to look the source code for getting more information. So let me close this and use JADX. The reason why I am using JADX is I think the decompilation is more cleaner in JADX than GDA. Okay, so let me wait now and let me go to the package name and the main activity. Okay, so if you look at here, we can see a comparison and we can see the good toast message and the bad toast message. Okay, this is the one we see if you enter the wrong password. And after that, we can see if you get here, it will set the text view to cracked 3. and there is a comparison here. So what is this comparison? Okay, it looks like it is using a string from an external library. Okay, and it is saying string from JNI. So if you look above, this is string from JNI method. Okay, and it is loading a library crackme3. And if you want to look for any libraries, you have to go to the resource section. So resource lib. Okay, now you can see the libraries. Okay, and this is the library. In order to find the password, we need to analyze this library. Okay, so firstly we need to dump this. So we can use our APK tool to decompile this and get this library first. Okay, we'll be working with ARM. You can also work with x86. It depends on your choice. I will be working with ARM because this is mostly using an ARM platform, because our mobiles are mostly using an ARM architecture. I'll just close this. No, and we can open our easy APK tool. Okay, let me drag and drop the application and press on decompile. So the main thing about this crackme is we are not patching this. Okay, we need to understand how this external library is validating our password. Okay, that is the main purpose of this crackme. We can patch it if you want, but that is not our main purpose here. Our purpose is to learn how this app uses this library to validate the input. Okay, as you seen before, it is loading a string from the external library. As it is using an external library, we need to look into the external library and see what the string is. Okay, so the decompilation is now successful. Let me go to the decompiled APK folder and crackme3, and let me go to the library section. So I will be dealing with ARM7. So this is the library file. We can see that it is ending with a .so, shared object. Okay, so in order to analyze this, you can use tools like IDA, binary ninja, etc. So I will be using Gidra. Okay, so you can use any of that. I will be using Gidra. So let me try to open Gidra. Let me type Gidra on my search bar, and this is my Gidra. Okay, let me click on it. And we can wait. Okay, it's loading. So Gidra is a very popular open source tool. You can use it. I prefer Gidra over binary ninja, so that's why I'm using Gidra. So this is the Gidra interface. Let me close this, and if you look at here, I already have a project. Okay, so let me create a new project. So I will click on file, new project, and I will click on non-shared project and press on next, and you can put any project name. I will just type Rebates 2 and I will click on finish. Okay, now our project has been created. Now let's drag and drop our library file. Let me drag and drop this into here. Okay, and you can just, it shows us the details of this file, and we can just press on OK. Okay, it will now import the file, and now you can see some details of the files again, and you can click on OK. Now what you have to do, now you have to double click on this. Okay, and it will open the code browser. Let me wait. As you can see now, this is the main interface of the Gidra, and you can just press on S to analyze it. and you can just check the default options and press on analyze. Okay, we can wait until this loads. You can see here the file being loaded. I guess everything is now loaded. So let me locate the string which is sent from this library. Okay, what you have to do is you can go to the classes and you can look for main. Okay, you can search for main. You can just type main here. Okay, and you will see our package name here, that is Java 82001 crackme 3 main activity string from JNI. Okay, you can just click on this one or this one. Okay, and now you can see this is the pseudo code and this is the ARM equivalent. Okay, so as this is using C, you can see the disassembly, ARM disassembly, as it is using ARM platform. Okay, if you use the x86 version, you should have seen x86 64 assembly or x86 assembly. And let me locate what is the string being sent here. Okay, if you look at here, you can see a string password 1337. I highly doubt that this is the string which is the string used for comparing our input. So I guess this is the only suspicious string here. There is no other string in this section. So let me do a string search. Okay, there is an easy way to find all the strings in this library. You can just go to window and click on define strings. Okay, and it will print all the define strings. Okay, so let me just increase the size of this window and we can see all the strings defined in this library. There is nothing interesting so far, and we can just scroll down, and if you look at here, there is this password 1337 and this basic string. So these are the only suspicious strings we've seen so far. Okay, so let me try this one and this one. Let me mirror my phone screen and check if password 1337 is the correct input. Okay, so let me pause this video for now. So I mirrored my phone into the laptop screen and this is the interface of our application, and let us now just type our password which we got from GitHub. Okay, it was password 1337. So let me type that password 1337. Okay, 1337, and let me click on check. Wow, it was the correct password and it prints out, wow, you got it. So this is the good toast message and we have successfully solved this crackme. Okay, so this was the correct string which was stored in our library. Okay, so this is the one way to do it. Another way is to patch it. Okay, I don't recommend patching it because I wanted to show you how to analyze the loaded shared object. Okay, that was the purpose of this main crackme. Or you can just patch it if you want. You can just try it out. You can just go to the decompiled folder. So let me go to the decompiled folder. So this is the crackme 3 and the smali. Okay, you can go to inactivity and we can locate for the good toast message and the bad toast message. Okay, so this is the bad toast message and the good toast message. You should look for a smali conditional jump here. So as you can see now, there is a EQC and EQC, and here is the label. So we can go to this label, that is conditional underscore 0. Where is conditional underscore 0? Conditional underscore 0 is here. This conditional 0 is executed if you enter the wrong password. As you can see, our wrong message here, oops, try harder. So I guess this is the portion we want to execute because it has the good message. Okay, and you can see that it will set the text view to cracked XO3. Okay, it has also the toast. Okay, so what you have to do now, we have to invert this condition. As you look above, it is loading the string from our library which we seen in our GitHub. It loads the string password 1337 and it will do the string comparison and it will return a boolean and it will be moved to p1 and it is checking if p1 contains 0. EQC means equal to 0. Okay, if p1 contains 0 it will go to conditional 0, and as you know conditional 0 contains our back toast message, oops try harder. And if it doesn't go to this part, it will go on to the below code here and it will execute our good toast message and it will set the text to cracked XO3. So as you know, it will load the string from our shared object and it will check if that string is equal to our ended string. If that's the case, it will return true. If it returns true, as you know, this is boolean, so it will be returned to p1. If true is the value, it will be 1. Okay, so in our case we don't know the password, so we will be entering a wrong input key or input password, so it will return false. False will be 0. Okay, then here it will check if p1 contains 0. If the input is not correct, it will contain false and it will contain 0. So if that's the case, it will go to conditional 0. That's why we are getting this bad message. If the entered password is correct, it will contain true and this method will return true and the p1 will contain 1. So when it checks if p1 is equal to 0, p1 does not contain 0. So it will not go to this conditional underscore 0. It will go to the code below here. Okay. As a result, we will get the good toast message and it will change the text view to cracked XO3. So in order to patch this, you can just directly change this to its opposite smali conditional statement. So that is NEZ. Okay. So you can easily change this to NEZ. Okay. So you can just try it out by yourself. I'm not showing here. You can try it out yourself. I'm not patching this and showing you this time. I hope you understood the logic here, and that's all for this video. So I hope you understood how to extract the library from the application and how to look for the strings in that using GitHub. Okay, thank you. I will be seeing you in the next video. Bye. Welcome back. In this video, we will be solving another CTF application. The application we will be reversing is this crackme 4. So this is a Flutter application. Okay. So from our another videos, we already solved Java based application. Okay. So in this video, we'll be trying something different. This is a Flutter application. So we'll be reverse engineering this and we'll be solving it. Okay. So firstly, let me show you the application in my phone screen. Okay, let me pass my screen into the laptop screen. As you can see now, this is our crackme interface and it has an input field and it says enter key. Okay, let me enter some random key and press on the check button, and when I press on the check button it says wrong key. Okay, let me try again with some another input and let me press on the check button. It again says wrong key. Okay, so this is similar from our last Java application. We need to find the key so that it will print out the flag. Okay, so let me now close this and let us reverse engineer this application so that we can find the flag and the key. Let me navigate into my Android tools. We can just decompile this using easy APK tool or APK tool. There is no difference in this methodology if it is a Java or Flutter application. Okay, we can just use the same tool. So let me open ECAPK tool and go back. Okay, it is now open, and let me drag and drop our crackme 4. We can now press on the decompile button. Okay, so I will just press S. We can wait until this decompiles successfully. Now the application has been decompiled, and let me now navigate into my ECAPK folder, and we can just navigate into that, and we can go to the decompiled APKs folder. Now if you look here, we can see the crackme 4. Okay, so we can go into that, and as you already know, this is a Flutter application. So how will we identify if this is a Flutter application or if it is a Java application? So the first thing to do is we need to go to the lib folder. Okay, and we can just go to the ARM7A, and if you look here, we can see a library called libflutter. So this indicates that this is indeed a Flutter application. Okay, so this is the key thing to keep in your mind if you are checking if the application is written in Java or Flutter. So this is one of the indicators that this application is written in Flutter. So now the next thing is to find out the source code. So in this Flutter application, it is very difficult to reverse engineer this. Okay, we cannot get the decompiled source code like Java. All the source code will be in this libflutter.so. This is a shared object. Thing to do here is we need to find the key and the flag, right? So what we can do is we need to extract the string from this libflutter.so. We can just use strings utility if you are using Kali or any other Linux machine, but as I am using Windows, I will be using a utility called strings. I will provide the link of that utility in the resource section. Let me just show you that. So this is the utility that we'll be using to extract strings from our shared object. So I will provide the link in the resource section. This is only 534 KB in size. I will just download this for you. I already downloaded this. This is a zip file and you can just extract that. Okay. So this is similar to the strings utility in the Linux command line. So nothing different here. So I'll just minimize this, and firstly we can copy this both shared objects. Okay, I initially said that our hard-coded string or the flag will be in this libflutter.so, but there is also a chance that it might be in this libapp.so. Okay, so we need to copy this both, and we can just extract the string from both these shared objects. Okay, so I'll just copy this and I will just go to, so this is the extracted zip file, and this contains 3 exes: strings.exe, string64.exe, and string64a.exe. So we'll be using this strings.exe. Let's firstly paste this shared objects, and I will just replace these two. Okay, so now let me open cmd. This is a command line utility, as you know, and I will just use this strings.exe. We can see some flags here. So firstly we need to specify the name of the file which we need to extract the string from. So firstly we'll be looking at libflutter.so, and I will be just saving the strings in a file. So let me put an append sign, and let me type the name of the text file which we will save the strings to. So privates.txt. Okay, and let me press enter. Extracted all the strings from the libflutter.so and saved that into strings.txt. So let me open that, and now we can see many strings here. Okay, so the next step is to find out the key or the flag. We can just do this by searching our bad message and looking for the strings near that. Okay, so our bad message was incorrect key, if I remember correctly. Let me check again what was the bad message in our application. So let me open my phone and check it. So it was wrong key. Okay, so let me just do an control F and press and type the error message or the bad message which was wrong key. Okay, and okay, there is nothing, so it says it cannot find any string called wrong key. So I guess there is nothing in this libflutter.so. Let me try in the libapp.so. Okay, so let us open our command line again, and we can open our strings utility once more, strings.txt, and we can specify the name of our library, which is libapp.so, and we can just save this in another text file. I will just call this reverse2.txt. Okay, so it is done. So let me open that, search for the bad message again. So wrong key, it is already filled in here. So okay, so it again says it cannot find anything as wrong key. So let me change the W to capital. Again it says it cannot find anything as wrong key. Okay, let me just untick this and click on find next, and now we can get a hit, and now we get a hit. Okay, so this is our wrong key, and we need to look for something near this. So we can look for any suspicious strings near this. Okay, you can see something here, so we can just look below and we can just keep looking for something interesting. Okay, nothing so far. So let me do one thing. I will do a search again with only key. Okay, so let me just search for something. So let me search for a string which has the keyword key in it. Okay, we can press on find next. Okay, this is not interesting, and let me do and find next. So this is our wrong key, and next it says key down. Okay, this is not much interesting, but let me try again, and this is the key from keyboard. We can keep looking until we get something interesting. I'll be writing down if it hits something interesting. Okay, and this J1A key is interesting and key RIT is interesting. I will write this down somewhere. Okay, so there are a lot of keys. So let me do another search for correct. So correct. So we hit something, it says correct key, and there is a WK here. Okay, so we can also write this down and check this one by one. Okay, so I already copied some of the interesting strings, and let me now check it one by one. If any of that string worked, I will cast my phone screen into the laptop and I will show you there. Okay, so let me try the strings one by one. If that is correct, I will show you. Okay, so let me try this one by one. So for now, I'll be pausing this video. So I tried all the strings obtained from the shared objects, and one string actually worked and gave me a flag, and the string was correct key. So let me show you that. If I just enter correct key and press the check button, it will show us the flag. Okay, so the flag is flag cracked. Okay, we have successfully reverse engineered the Flutter application to obtain the key, and we have successfully obtained the flag. And if you know the format of the flag, you can actually just get the flag. Okay, let me show that too. I'll just close this, and I'll just close this again. Okay, so let me go to the strings. So the extracted strings from libapp.so is saved in reverse2.txt, So let me open that and let me just find the flag and flag and press on next. So we can try that. So let me just put on one curly brace and let me just press find next again. And now if you can see that we can find our flag easily. So this is another way to find the flag. But in this way you should know the format of the flag. So this is all for this video. I hope you understood how to reverse engineer this and extract the strings from this Flutter application. So I'll be seeing you in the next video. Bye. Hello, welcome back. In this video we'll be doing another CTF application. So in this video we'll be reversing a React Native application. Okay, so all this in this previous video we looked on Java and a Flutter application. Now we'll be looking at a React Native application. So let me show you the application. So this is the application that will be reversing crackme file, and application will be provided at the resource section like before. Now let's explore the application. So I will just mirror my phone screen. Okay, so let me connect my phone interface to the laptop. So as you can see now, this is our application's interface. It has a edit text and it says enter the passcode, and we have a submit button and there is a message right down below. So let me enter something random and press on the submit button. And if you just press on the submit button, it says better luck next time. So let me try again with one more input and press on the submit, and it says better luck next time. So this is like the application we did before, and we need to find the right passcode so that it will set the good message like congratulations or something else. Okay, so without wasting any time, we can just reverse the application and see how this works. Okay, so let me just quit my mirroring and let me go to our folder. Now let me navigate to my Android tools folder, and we can see that this is our application crackme file, and we can just decompile it like before. Okay, even if this is a React Native application, there is no change in the decompilation process. We can just use a easy APK tool or APK tool. So let me use easy APK tool and just decompile this. Okay, we can go back and drag and drop this application. So let me do that. Now let's press on the decompile button. Okay, and I will just press S and we can wait until this decompiles. Okay, now we can see that our application has been successfully decompiled, and we can just navigate into the easy APK folder. So we can now go to the decompiled APKs folder, and we can go to our application name, which is crackme file, and we can navigate into that. So as you can see now, this is our decompiled application. So there are many smali classes than before. Okay, but if you just navigate into that, these classes or this decompiled APK smallies is mostly referring to other modules. These are not the smali decompilation of our main application source. This is mostly the smali classes of other external modules used by the application. So the first thing, if you get an application, so you need to identify if this is a native application using Java or Kotlin, or if it is using another language like Flutter or something. So firstly, we need to confirm this. Okay, so as you know, this is a React Native application. So we need to confirm this if this application is using React Native. Okay, so how to identify that? We just need to navigate into this assets folder, and we can see that it follows a different structure. from our previous native application. Okay, so there are bunch of these certificates, and there is something called the app.bundle and app.config and app.manifest. So this app.bundle, app.config and app.manifest indicates that this is a React Native application. These are the key things to keep in your mind if you are checking for what application you are decompiling. Okay, so if you see these three, you need to confirm that it is indeed a React Native application. Now we know that this is a React Native application, right? So the next thing is to find the decompiled source code. So this will be in this app.bundle. Okay, so you can just open it using Chrome or Mozilla. So I will open this in my Mozilla. So this is the source code, but as you can see now, this is not properly formatted, and it will be very difficult to read this. This is the one way to do this, but as you can see now, this is unformatted and difficult to follow, but we'll be looking in another way just in a minute, so bear with me for now. So we can just use this to find out our password for the application. We can just easily find the password for our application from here. We don't need to even properly format this. Okay, so how will we do that? We can just search for the wrong message. Firstly, we can just do a control F, and we can just search for the bad message. So if I remember correctly, the bad message was better luck next time. If you enter the wrong password, it will tell you better luck next time. Okay, so that was the error message, or you can just call it as the bad message. So I will just type it out using control F, and we can just type it out here, better luck. So if you look at here, we can see that better luck next time. And if you look before, we can see a congratulations. So this is obviously our good message. Okay, and after that we can see a strong password, and it is checking if it is equal to T, and there is a question mark here. So what I think is this T contains our entered input, and it is checking if it is equal to this text, hard-coded text, and if this is equal, it will print out congratulations, or else it will just set this better luck next time to our text view. Okay, so I guess this is the password which we need to enter to print out this good message. Okay, so let me try this in my phone and cast this into my screen. So I just casted my phone screen into my laptop, and as you can see now, this is my phone interface. So we can try the password which we found out, which was strong password. Okay, there are digits in between, so we need to type this carefully. So let me type this strong. Okay, password. Okay, and let me press the submit button. Oops, there was something error. So strong, and okay, the A was 3. I'll just change that to 3. The D is also capital. Okay, let me change that to capital D, and now let's just press enter. We can see that our text view is changed to congratulations. Okay, so this is one way to solve this. So we can just solve this very easily by just finding out the bad message and looking at the code near that. We got the password because the password was a hard-coded string. So if it contained any other logic, we need to understand the code. Okay, so let's do that. So let me close this, and let me close this too, and let me go into my folder. Let me also close this. Okay, now we are in the assets folder. So what we have to do is we need to create a HTML file. So let me do that. New, and we can just go to a text document. Okay, let me give it a name, privates.html. Okay, and we can just press on S, and let me edit this. Okay, so we can just open with this Visual Studio Code. We can just You can just also use it using Notepad. Okay, I'm just using Visual Code because it's more easier. So let me wait. Okay, now we can just write some simple HTML code. Okay, HTML. Okay, now we can just set the head, and we can now define the body. Okay, now what we have to do is we can define a script tag, and script src is equal to, we need to specify the name of our bundle. So what was the name of our bundle? It was app.bundle, right? So we can just specify that in our double quotes, app.bundle. Okay, you should recheck the name and make sure there is no error, and we can just close this tag, and I will just use another tag here, h1 for head, and I will just type hello here, and now we can just save this, save, and we can just minimize this, and we can see the HTML file, and we need to open this using Google Chrome. Now we can open this using Google Chrome. Okay, let me right click and open with Google Chrome. Okay, it opened successfully, but it's not showing the heading. I think it is because of the, I didn't put the doc type tag in the document, so that's why it is not printing the h1 tag. Never mind, it is not that important. So the next thing to do is we need to go to the developer tools. So we can just click on these three dots here and go to more tools and developer tools. So in here we need to go to the sources. Okay, we need to click on the sources tab, and it is already in that, and we can see that it loaded our app.bundle. So we can just double click here and we can see our source code. Now we can just click on pretty print. Okay, now it will just format our source code neatly so that we can understand this better. So this is the another way to see the source code more clearly. So this is another way to get the source code more neatly. So I guess this is pretty much understandable than before. So now we can just search for our bad message, which was better luck next time. So we can see here this T contains our ended input, and it is comparing with strong password, and if it is both equal it will print out congratulations, else it print better luck next time. This is all for this video. I hope you understood this. So we'll be seeing you in the next video. Bye. Welcome back. In this video we'll be looking at another CTF application. So the application we'll be looking into is crackme 6. So we need to find the flag from this crackme 6. Okay, so let me show you the application looks like in my phone. So let me just cast the phone screen into my laptop. So this is the application, and as you can see now there is no input field or such anything like that. There is only a message called find the flag. Okay, so we need to find the flag from this application. The format of the flag is flag and two opening and curly bracket. Okay, so we need to find the flag from this application by reverse engineering it. Okay, so firstly I will just close this, and I will do this using both Linux and Windows. Firstly, let me open my Linux machine, and you can use anything which is of your favor. I'm using Ubuntu. Okay, so this is a custom lab for ARM exploitation, so I'll be using this for solving this. Okay, so this is our crackme application. So the flag of this application is a hard-coded string. So we can just easily search for that string using the strings utility in the command line. We can just filter out the flag string using the grep command as well. So as you know, the format of our flag is flag opening bracket and there is a value. It may be a string or anything, and after that there is a closing bracket. Okay, so we can just filter out the word flag from these strings. Okay, so let me use the strings command. Firstly you have to type strings and give the file name, which is our crackme6.apk, and after that if you just press enter, it will print out all the strings from the crackme6, but it will be difficult to filter out the flag from all these strings. So what I will do is I will just pipe the output and use the grep command to find the flag from it. So I will just use grep, and what we have to filter out for flag, and if I just press enter, we can see now this is our flag. Oh, you found it. So this is how to solve this challenge using Linux. So the other way is you can just use tools like GDA, JADX or anything else. Okay, so let me show you that too. So I will just go to my folder and I will just open JADX. So we can just open our crackme in here and it will load our application into the JADX interface. So let me give you a simple tip. So if you are looking for hard-coded strings, there is a great chance that mostly it will be defined in the strings.xml file. So you have to look for it first. Okay. So in this application, we need to find the flag, right? So let me go on and check the resources and check the strings.xml file. So firstly, we can go to the resources and we can see this resources.arsc and we can see a plus sign here, expand that, and after that we can see the resources folder. So we can just expand that too. And after that we can see this folder called values. Okay, we can just expand this and we can see that there is a file called strings.xml. So if you double click on this, mostly the hard-coded strings will be defined here. Okay, so you can see the app name is crackme6, and if you look below we may find our flag. If you look at here we can see our flag. Okay, so the flag is, oh, you found it. So this was defined in our strings.xml file. This is another way to look and find for the flag. Okay, so if you don't see the flag in this defined strings, you can just search for all the strings using this search command. Okay, so you can just click here and you can just search for the text. Okay, so if you know the format of the flag, you can just type for the format and search for it. So this is also another way to obtain the flag. So that's all for this video. I'll be seeing you in the next. Okay, bye. In this section, we'll be looking into ARM reverse engineering. So you all will be thinking, what's the need for learning ARM reverse engineering in this mobile reverse engineering course? So to explain that, if you look at the most of the applications released nowadays, it may be using external libraries or shared objects. So if you need to analyze or change anything to that external library, you need to learn about ARM. Why? Most of our mobile phones run on ARM. So in order to understand or change or modify anything in that, you need to learn about ARM basics and ARM reverse engineering. Nowadays, most of the phone run on ARM64. So in this section, we'll be looking into ARM32 only. So it's necessary to have some amount of basics in ARM assembly. So if you don't, please check out the codes in the description. You can learn some assembly and come back, or else you can learn it somewhere else and come back again.
In this video, I will walk you through our lab setup. So we'll be using Assyria Labs 1 and Assyria Labs 2. So we don't need any hardware devices like Raspberry Pi or something. We will be using emulated labs. Okay. So I will go on to Google and I will just type Assyria Labs, and if I just press enter, we can see the Assyria Labs link. And if I just open it in another tab, so we can go to this Assyria Labs tutorials. So this is a great place if you want to know and study about ARM exploitation. Okay, we'll be looking some of the examples in this website, and we can wait until this loads. So, and we can go on to a lab environment. So these are the two labs, so we'll be needing both of these labs. So if I don't have this lab 2, these two are running on different versions of Ubuntu and two have different versions of ARM. And if I look at here, so this is the link for downloading our lab. Okay, so you can go into any of these links and download it here. Okay, so the password is Assyria Labs, and there is also link for emulating it manually, so you don't have to waste any time to emulate this by yourself. You can just download this lab, it comes with everything. So you can just download this Assyria Labs 1, and if I just go below, no, if I just click on here Assyria Labs 2, so this is the Assyria Labs 2. So, and you can just download it using Google Drive link, and this is the password of the zip file. It will be a zip file, you can just download it and extract it. So this is the credential user and user. So if you don't want to download this lab, you can just emulate it using Kemu. Okay, so all the instructions are provided here. You can just download this, but this is bit complicated. Okay, so it will be better if you just download these labs. So you should need Assyria Labs 2 in order to work with most of our latest tools like Binary Ninja and Gitra, etc. Okay, so you need to download these Assyria Labs 2, and this comes with ARM version 7, and Assyria Labs 1 come with ARM version 6. Okay, so you need both, and we'll be mainly looking on ARM version 6, but if you want to work with the tools like Binary Ninja and Hydra, you should need this Assyria Labs too. Okay, so after downloading this, you can extract it using any other, like WinRAR or WinZip, etc. After that, you can download your VMware or workstation. So I have VMware. So after extracting that, mm, so after extracting that, there will be a file called, I will find the location. Yeah. So if you just extract this, you will get these files. And if you look here on this file, that is Assyria Lab v1 vmx. So this is a VMware file. Okay, VMware virtual machine configuration. So if we just double click this, it will open our VMware, and you can just press here to start our lab. Okay, so after that you should enter the credentials. So that's all for the lab of this codes. Okay, bye. In this video, we'll be doing a small crackme. So what is a crackme? Crackme is a small program which helps us to practice our reverse engineering skills. Okay, so it works like a small password checker, and we can look at a small crackme now. And this is the source code. And if I just show you the source code, it has a hard-coded password, and we will pass in something as an argument to this program, and if this matches the hard-coded password, it will say it's correct, and it's no, if it's not, it will say no, it's not correct. Okay, so this uses a string compare function. Okay, and we can just compile it first, and I will say pcc and crackme 1. Okay, we can wait. So if I do an ls, so this is our crackme, and we can run the program, and if I just press enter, it will ask me for one argument. That should be our password. So it says AAA is not correct, so this is the hard-coded password. So imagine you don't have the source code, and this is a program that you want to crack. Okay, and before that, before just doing this program, you need to gather some information about this program. So you can do some basic things like finding the strings inside this program or analyzing the binary, whatever. So firstly we will do and string analysis on this program. Okay, so we want to find all the strings inside this program. So imagine if the password is stored as a string, in this case, which it is stored as a string, right? So if we do an analysis on this crackme, we will get the password very easily. So I will just say strings and crackme. It will print out all the strings inside this crackme. So if you look here, this is our password. So you just have to copy that, and if we just run our program and pass this as the argument, and it says yes, this is the correct password. Okay, and similarly, if you want to see the disassembly of this program, you can just say, you can use a tool called obj dump. Okay, and I will just say obj dump and help, and we can see all the usage of this commands. Okay, and firstly I will do a disassembly. Okay, we can use D for disassembling and capital D for disassembling all the sections. And if you want to say if you want to get some overall information about the file, you can just say obj dump and f and specify the name of the file, which is our crackme and 1. So this will gives us a small information about the program. So it says it is a ELF architecture, and it is a F32 LitR format. Okay, so now we know our file is in ARM. Okay, and we can also do a disassembly and obj dump -b and crackme. So it will do a disassembly. Okay, and we can go on the main section. So we can look at here, this is the disassembly of our main function. Okay, so we can see the print function, and here is our string comparison. Okay, so it is checking the ended value and the hard-coded value in our program is the same using the strn compare. Okay, and returning something in the R0 register. Okay, and now we can load the program in our GDB. So I am loading our program in the GDB, and we can wait. So the program is now loaded, and we can do a disassembly of the main. If you look at here, we cannot see any functions name, right? For example, we cannot see our string compare, or we cannot see our printf or anything. We can only just see the branching and to a specific memory location. Okay, we have to scroll up so we can see the function's name in this obj dump. Okay, so you can see the string comparison here. Okay, so what actually happens in the program is what we entered and the hard-coded value is compared. So this comparison is done using the strncmp. Okay, so before that I will show you the source code if you guys have any doubt. So I will show you the source code, and this string compare is what we are seeing in here. Okay, so this is the same thing. And so if you look at here, we can see our string compare, right? So what you have to do is we have to look for that in our obj dump disassembly, and we can see this is the strncmp. Okay, so we can look at here, it says bl 10374. So if you look at here, 10374, so we have to put a breakpoint here. Okay, so we can load the program once again in our GDB. So I will just say crackme 1, and it's loaded, and we can do a disassembly once again. And as you know, this is the string compare. So bl 10374. Okay, so I can just put a breakpoint here, and I'll copy this, and I'll just say break at this location and run the program using R. So before that you have to put something as an argument to this program. So this program accepts command line argument. So what we are entering after the space of the R will be given to the program as the argument. So this is what we are entering as password. So I will put ggg and start the program, and we will wait. So our breakpoint is now hit. It says reason is breakpoint. So this is a strncmp. Okay, it's comparing what is in our entered value and the ultra super password, which is a hard-coded value in our program. So we don't have to get inside this string compare function. We can just say ni, and it will execute all this code inside this function, and we'll move on to the next instruction. So I'll just do ni, and if I just look here, if I just look R0, it's having a negative value. So what actually happened here is the hard-coded value, that was the ultra super password, and the password we entered, which was ggg, is compared using the strncmp, and the value is returned in R0. So you can see R0 holds a negative value, and if I do an SI, this negative value will be copied to R3. Okay, and after that we can see a CMB which compares 0 with R3. Okay, so if the comparison was the same using the CMP. So if the hard-coded value in our program, it was the ultra super password, and what we entered was the same, R0 would contain 0. So I will show you that again. I will run the program and I will copy this password and press enter, and it is starting the program once again. And if I do an NI, R0 will contain 0. So R0 contains 0 and the negative flag is, oops, the 0 flag is set. Okay, so if the comparison is the same, means the value we entered and the hard-coded value is the same, it will return, the strncmp will return 0 in R0 register. Okay, so the return value is given in the R0 register, and we can start the program again with the wrong password, and we can do an NI again. We can do NI. So from here we know this comparison will not set the 0 flag. After that we can see a BEQ. Okay, so what will happen here? If I just do an NI, it has set the negative flag. And if we look here, it says the branching is not taken. Why this is not taken? Because the 0 flag is not set. So BEQ only works if the 0 flag is set. So it is not taking the branching because the 0 flag is not set. So if I do an NI, the branching is not branched. Okay, so the execution doesn't move to here, it will just execute the next instruction. Of course this will be executed, but it won't branch to this label. Okay, and we can do an NI again, and if I just press C, it says GGG is not correct. So we so from all this execution, and we understand that we need to branch to here. Okay, so if we don't branch here, we might get this message. So is that wrong location? We don't have to get this message, we have to get the right message. Okay, so we have to branch to this location and we have to analyze what's in this location. So initially we didn't branch to this location, and see, if we don't branch to this location, we will get this message that will say GGG is not correct. So we don't have to go to this location which says the password or anything is not correct. We have to go to the section which says the password is correct even though we entered the wrong password. This is the normal execution of the program if we enter the wrong password. So if we enter the right password, it would branch to this location and it will tell us the password is correct. So what we entered is the wrong password, right? So this won't branch to this location and it will move on to the next instructions. So that's why we are saying, if we continue this, it will say the password is not correct. Okay, so we have to change the behavior of this program even if we enter the wrong password. So that is reverse engineering is all about, right? So from this we can analyze that this section or this instruction is something we should be suspicious of. Okay, so I will run the program once again, and I think the breakpoint is already set, so I don't have to set it any. So we are aware that if we don't take this branch we will get this message. Okay, so we will get the wrong message, and we can do an ni again. So as we know, R0 is moving to R3 and the comparison is done here, and after that comparison, if the zero flag is set or not set, it will do this branching. So what you have to do is you have to set the zero flag. You can set the zero flag using that set command. You can just Google it. So I will do here is give the value 0 to R0, so that from here if the comparison or occurs, it will set the zero flag. Okay, so I will just set zero flag to value 0, and if I just execute that, this 0 will be copied to R3. Okay, and if I look at R3 now, R3 contains 0, so it is comparing 0 with 0, which will definitely set the 0 flag. And it says the jump is taken because the 0 flag is set. And if I do an SI again, we are in this location. Okay, note that we will be in this location. Okay, if we look at here, we can see main plus 140. So if I just press C, it says GGG is correct, even though the password is not the hard-coded password in the program. So that's how we do it in our GDB. And in the next video, we will be using various tools like Ghidra, Binary Ninja, or Hopper to patch this file to enter whatever we want to enter, and it will display a correct message. Okay, bye. In this video, we will be reversing a simple binary using Ghidra. So Ghidra is a great reverse engineering tool which was developed by NSA. So we'll be using Ghidra to look into a small binary, and we'll be analyzing it using Ghidra. So if you want to get Ghidra's shortcuts, you can just type Ghidra cheat sheet in Google, and this website uses a overall cheat sheet on using Ghidra. And firstly, I downloaded Ghidra and I will open the folder. So this version of Ghidra requires a Java JDK of 11, and I can just run it using, so this is the file, and we can run using our command line, just saying /ghidra run, and it is saying Java runtime not found, but the Java runtime is already installed in this VM. No, it is not already installed. I installed it by myself, and we have to just export the binary. So if we look here in the docs, and this is the installation guide, we can use the browser, and if we look below, and we can scroll up, and there is just type export. So we have to export this path. Okay, we can just copy this, and it is saying path of the extracted JDK directory. So I will move on to our folder of Ghidra, and I will paste this, and I can change the path to, so in this OS or in this Ubuntu, the default of extracting a JDK will be loaded in here. Okay, that is usr lib and jvm and Oops, this is not USR. Okay, USR lib and JVM. I think so. JVM. Yes, is that JVM? You can look. Yeah, it is. It was JVM. So JVM and JDK 1.0.10, and we can just press enter, and now we can run our git again. So we have to wait until this git loads. So our git is started, and we can just, oops, it's already loaded. Okay, I can just close this and I will give a fresh start. Okay, so yes, I will cancel all of this, and yes, and yes. Why this is in not closing? Yes, so it is closed. I will show you a fresh start. Okay, I will delete all of this again, and okay, I will close this and start gitra once again, and we will wait, and we can close this tip. And firstly you have to go to file and say new project, and you can just press next, and you can put the name of the project. I will just say labs, and click on finish. So this is the new project lab folder, and you can just drag and drop the binary into here. Okay, so if I just go to my desktop, and so this is our binary ninjas folder, we can see the binary inside here. Okay, so what I will do is I will drag and drop this binary into here, and it will import itself, and we can just press OK with the default settings, and the binary will be imported, and we can see our information about the binary. Okay, it's ARM and the processor and everything else. Okay, and you can just press OK. So the binary is loaded, and now we have to go to the main gitra interface. For that we have to just press double click, and if I just do a double click here, it will go to the code browser, and this code browser is the main interface of the gitra. So it will say this crackme has not been analyzed, so would you like to analyze it now? I can just say. So the program is already loaded, and if you look here in the program tree, we can see the different sections of our program, the bss section, data section, and else everything. And if we go downwards, we have different folders. So the programs sections are arranged in different folders in gitra, so it will be easy for us to browser and look on things. Okay, so if you look at the import folder, it will show us the imports used by the program, and similarly the exports, and this will have all our functions and labels, classes, etc. So you can also use this filter option to search for something. So if I just type main, it will show you the main. I can just double click, and if you look here, this is the disassembly, and also there is a pseudo decompilation similar to binary ninja. Okay, and so if you look here, the branching instructions are showed by these flow lines here. Okay, and similarly we can see the strings here. our ultra super password. This is the similar binary we used in the binary ninja, so that's why I'm not elaborating it so much. Okay, and so we can see there is the variable which the return value of this function is stored, and we already analyzed that using our disassembly, right? And if we cross check this, so the return value after this is stored in R0 and is copying to R3, and it is using a CPY. So this CPY is same as the move instruction. You don't have to worry about it. Okay, it is the same move instruction. After all, Ghidra disassembles a little different than binary ninja. Some minor changes will be seen in the program. Okay, we can see our ultra super password, and it is compared using the str and cmp, and if the return value is 0, it will say the password is correct, and else it will say the password is not correct. Okay, and we can see the disassembly and the branching instructions are used by this flow lines similar what we seen in binary ninja. Okay, we can see the flow lines here, and we can also see the text, and if you want to use the graph you can just say graph and block flow, and it will generate the graph. Okay, and this is a high level overview. If you want just a low level overview you can just press here and it will show the graphing. Okay, so that's all for Ghidra. And if you want to look at here, this is our strncmp, and after that there is another comparison how the return value after this comparison is stored in R0 and it is similarly copying into R3. So this CMP is similar to the move instruction. This this copy instruction is used in Ghidra because its disassembly works like that. Okay, so you don't have to mind that. It is similar that of the move instruction. And after that there is a CMP comparison which compares R3 with 0, and after that it is a branching instruction. So the comparison results in 0, and it will set the 0 flag and it will branch to this label which says the password is correct. If the password is not correct, it will go on to this section which will say the password is not correct. So it won't branch to this section, it will just move on to the next instruction after this branch instruction. Okay, and so if you want to patch this you can use this patch option in this Ghidra. You can just say patch instruction and press OK, and you can use various things in this patching. But the problem is the Ghidra currently have a bug, so even if you patch this and export this binary it won't work. So that's the issue in Ghidra. So or else what you can do is you can copy this hex and edit this in a hex editor, but it would differ because ARM binaries are different. Okay, and oops, it is gone. I will show you once again. You can just press patch instruction, then you can edit everything. It will also show you the recommendations, and okay, so but sadly this won't work. That is a problem in Hydra. Okay, if you want to search for something, like if you want to search for a string you can just use the search and for strings, and I will just say search, and I will just say password. Oops, password, and we can see it is in this location, and if I just double click this will be in this section. So this password is of course stored in the data section. Okay, so that's all for the analysis of this binary in Ghidra. In this video, we will be reversing a small binary using binary ninja. So there is a tiny problem here. This OS doesn't support binary ninja or most of the reversing tools. So what we have to do here is we have to use the serial apps too. So we have to upload this binary to somewhere and we can analyze this binary using our serial apps too. And firstly, I will upload this binary using something called bash upload. Okay, so this is a command. You can just use curl and I will just type curl and bash upload.com and t, and we can specify the name of the file, and if I just press enter it will upload it, and this is the link. You can copy it here and I will paste it here for now. Okay, oops, it's not copied. This should be copied. I don't know why this is not working, and I will try once again. I will copy address, or I don't know why this is working. So I tried various solutions to paste that link somewhere, but it doesn't work, and I don't want to restart or reinstall this VM again, so I can do that. So I just typed it down from here. Okay, so I will, this is my Assyria Labs 2 and we'll be using binary ninja in here. Okay, I will navigate into binary ninja, and as you know, you can use that crackme we uploaded in the VM1. So I will check if this work again. I will copy this and hope this works. Okay, so I paste this. Yeah, this is working in this VM. I don't know why is that not working in that Assyria Labs Lab 1. Okay, so it is successfully downloaded crackme 1, and this is not the name. Is that, I just said crackme 1. Okay, but it is saying, oh, I see, there is also another file with the same name. That's why it's renamed to crackme 1.1. So I will delete both and I will show you again. We can just use wget and paste the link. Okay, so the crackme is now loaded here successfully, or downloaded here, and we can run binary ninja on this binary. Okay, so this is the binary ninja file, and I will just say binary ninja, and you can add this file, name of the file, and press enter. So this is a trial version and we can start it. Okay, this is the interface of our binary ninja. So there is a tiny, no, nothing is, so everything is okay, and this is the disassembly, and we can see here all the functions in our program, and the file is being loaded here. Okay, so I think it's already loaded, and we can go to the functions. Okay, you can see the main here. If you just double click on the main, it will show you the exact pseudo C code that it is generated intelligently. Okay, and if you want to see the disassembly, you can just say or press space and view in disassembly, and you can see the disassembly with some graphs which will help you analyze a little better. Okay. These lines show you the flow of execution, and we can see the address of these instructions here. Okay, and we can see how beautifully binary ninja has done for our analysis. Okay, so we can see each blocks and how this execution goes with these lines, and we can see the branching, and it says 10540, and this is our block, and this is our super secret password. So this is the password, and it is comparing firstly if that program has one argument. Okay, and similarly after that we can see our password is loaded into some location, and as you seen in our GDB video, this is our strncmp, and it's copying the return value in R0 to R3, and it is comparing it with 0. And here is where our branching occurs. BEQ, okay, branch equal instruction. And if we enter the wrong password, we will go to here. We can see the strings, right? And if we enter the correct password, we will go to here. And if you want to change this view, and you can just press on this graph, and you can see various views. And this is the byte view, and you can see the disassembly graph, and hex editor. This will show you the hex equivalent of our binary, and the linear disassembly, which will generate our pseudo C code. Okay, and you can see the strings in our program. Okay, and various things. So I will just go on with the disassembly graph, and we can just use our binary to load in various types. If you just press raw, it will show you the entire content. Okay, and we'll go with the else. And so this is the first look of our analysis tool, Binary Ninja. So Binary Ninja can do many things. We'll be looking only at a small basic level. So we can see the functions here. We will just click main, and main it will show you the pseudo decompilation of our program's code, source code. And we can go again into the disassembly. If you look here closely, we can see the names of the functions are clearly written. Okay, and it will save us all the trouble going through analyzing each code of block and predicting its output. If you just look at the block diagrams here, we can easily predict this block is responsible for the correct password, and this block is responsible for saying the password is not correct. So how did I identify that? We can just see the text. Okay, yes, percentages, this will be what we entered is the correct, and this says is not the correct. Okay, so we can easily assume this is the block which helps us to say the password is correct. So we have to just change the flow of execution to this block. Okay, so we can easily find the address of this block, and we can easily come to a conclusion that this is the block for patching. Okay, and we all know the logic of the program, right? So it's comparing the hard-coded value with the value which we entered, and if it's the same, it will say the password is correct. If it's not, it will say the password is not correct. And we can patch this to make the program go to this branch every time when we run the program. Okay, even if we entered the wrong password, it will say it is correct. So how to patch this, or how in the way we can patch this? We can patch this in various ways. Okay, firstly, you can just do it like what we did in our GDB. So we can just load the value 0 into R3, and it will set the zero flag and always go to here, or else you can just change the branching instruction. So I will show you to change the branching instruction, and I will just right click on here, and there is a patch instruction. Yes, patch, and we can say always branch, invert branch, or never branch. So if I say never branch, it will never go to this location even if you entered the correct password. So what you have to just do is always invert the branch. Okay, so it will do the opposite. So it is what we always do, or else you can just say always branch. So it will always branch to this location even if you enter the wrong password. So what will happen if we just change to always branch? It will gives us a direct branching instruction. Okay, so we will go to here even if we enter the wrong password. And similarly we can do a patch. Okay, if you want to just go back, you have to press here. Okay, and similarly if you want to edit this, let's look at how to go back in our edit. So yes, we can just undo this, and we are back to the previous state of our program, and we can just patch this using always branch. So it will also gives us the always branch instead. Oh, sorry, this is what we done, right? So I will go back again. Sorry, I was just okay. We can use patch and invert branch. So it will do the opposite of the BQ instruction. So it will replace this BQ with the BNE. So what actually happens here, we know how this works, right? This BNE goes or branches to this function or label if the zero flag is not set. As we know, this comparison not set the zero flag if we enter the wrong password, and it will go to here. So either way you can do it in many ways, or you can just patch or edit the current line and move the value 0 to R3, and this will do a comparison and set the zero flag. Okay, so you can do this in a various ways, and I will just go on with a simple one. I will just say always branch, so it will always branch to this location. And now I will export this file, and I can just say save as, and I will just say crackme patched, and I will save this. I hope that is saved. Yes, this is saved, and we will use the batch upload again to upload this. So I'll use curl bash upload.com and t, and we will specify the file name. Okay, patched. So this is uploaded, and we can copy this and paste it here temporarily. Okay, and I will go on to our Assyria Labs 1 and download it, and will show you the result. Okay, so I am in my Assyria Labs 1. So let's download the binary which we modified using binary ninja and check if the binary is working properly as we expected. So I can just use wget and paste the link. So this is the link, and it is saved as this file. Okay, and if I just do an ls, so this is the name of the file. So there are two of them, and I will remove one. and I can just type the name of the file. Okay, and this is our file, and I will rename it using our move command to crackme one patch. Okay, P stands for patch, and I will give that file a permission for being executable. And now if I do an ls, our file can execute. Okay, so I will run this file again and check if this is working. Okay, and I will give that a dummy password, and if I just press enter, yes, our binary has been successfully modified. So if I just put anything, it will say it is the correct password. Okay, okay, oops, yes, so it's saying our password is correct. Even if we enter any wrong password, it will say it is a correct password. Okay, and I can show you the disassembly using obj dump, and I will put the file name crackme1 p1. So if you go to the main, we can see the conditional branching is now changed to a direct branching to this location, which will say our password is correct. So that's all for patching the file in Binary Ninja. Okay, bye. In this video, we'll be doing our crackme using Hopper. So what is Hopper? Hopper is another disassembler, and it is also a debugger. So we'll be using Hopper version 3 for doing this crackme. Okay. So there is a Hopper version 4, but it doesn't support on this Ubuntu 18.4. Okay, it needs Ubuntu 20 or greater version. So I already installed Hopper. Now I need to open it. So I will just use the search option to search for Hopper, and it is a trial version. So I will just say try the demo. So there are some drawbacks if you use the trial version. You will see that later. Okay. And the hopper is ready. Now we can import our binary for disassembly. So I will just click on file and read executable to disassemble, and this is our crackme one, and I will just press open, and we can press ok. Now the program is being analyzed, and we can see the file information, CPU mode, and other things, comments or etc. And we'll be only looking at the basic level as usual, and it's being loaded. So this is the disassembly, and these are our different parts of our program. This contains the mostly our functions, labels, etc. So we can also search it using this search bar, and similarly if you just press on the string tab, we can see the strings. Okay, and this is our ultra super password, and we'll wait until this fully loads. Okay, so the background analysis ended. Okay, so we can go to the main as usual. So I'll just type in main. So this is our program's main. I will just press on main. So this is our disassembly of the program in the main procedure. Okay, and if I just scroll downwards, we can see, as in Gidra, these lines are used to represent the flow of branching. Okay, so we can also see the strings in our program need exactly one argument, and our password, which is a ultra super password. And there are other comments. Okay, argument 1 for method str and compare, string compare. Okay, and so if you want to see the pseudo decompilation of the source code of the program, we have a similar option like we had in our git draft. Okay, we can just press here and it will show the pseudo code. So this is our pseudo code. So it is not as clean but we saw in our git draft, but it's still useful. Okay, and this is the password and it is comparing. So if the comparison returns something other than 0, it will say the password is not correct. Else it will say the password is correct. So we can see that if the string compare not equal to 0, it will say the password is not correct. Okay. Else it will say the password is correct. And we can just close that. And if you want to see the graph of this, you can just press here, so it will show you the graph. So we can also export this as a PDF if you want. So this is the graph, we can zoom in and out. Okay, and you can just scroll it from here and there. So this is the graph, and I can close that. So in so the patching and debugging will not work in the demo version, and we can see mostly everything as we seen in our Gidra and Binary Ninja. So we can get an overview of our crackme. So that's all for analyzing our crackme using Hopper. Okay.